All right, welcome back to Packaging Con for room two. Our first speaker today is Ludovic Cortez from the Geeks Project, and he's going to talk about the packaging holy grail. So take it away, Ludovic. I'm going to add you to the stream, and you have the mic.
Thank you. So my name is Ludovic. I'm going to talk not so much about Geeks itself today, but rather about the packaging grail, or what I call the packaging grail. So in other words, what my horizon is in terms of packaging. So I know there are lots of package managers. We've seen lots of people, lots of different projects in this conference, and that's great. There's a lot of diversity. And so there is not a single packaging grail, I suppose. We all have different goals and different preferences. So I'm going to talk about ours for the Geeks project and for myself, I guess. But yeah, let me give a brief introduction if I manage to. All right. So I just need to regain control of my window. So, yeah, that's a fun thing with online conferences. You always get new things to learn.
Are you good with sharing your screen? Sorry.
Yes, but just Chromium is somehow messing with my Windows. Yeah, I'm sorry. Or is there a way I can share a PDF directly, Todd?
I don't know. If you send it to me, I could try to share it. I suppose we could do that. Or you were sharing before, so I guess what happened?
I don't know.
Do you want to quit and come back, and we could try that?
Maybe, yes.
That has worked for me before.
Thank you.
All right, Ludovic is almost back. Ludovic, are you still there?
Yes, I am.
Okay.
Working on it.
Okay.
Apologies.
No worries.
All right. All right, can you see my screen?
I can. I am adding you to the screen. Okay, you're good.
All right. So,
sorry
about that.
Take it away, Ludovic.
Yeah. Yes. So, just a little bit of introduction. So, I'm working on GNU Geeks, which is a universal package manager. So, we have very specific goals and very a specific Grail, I suppose, which we share with some other projects, but maybe not entirely, or we have different things. I'm actually into packaging since maybe 12 years or something, which is kind of ironic because when I got started into free software and GNU Linux, I always thought that packaging is uninteresting. So it's like, yeah, but it turns out that yeah, there are lots of things to do, and it's actually pretty cool. So let me first introduce our own packaging Grail, and then we'll see how it compares to others. So Geeks is a GNU project. We insist on providing free software, so software that users can study, can run as they wish, can modify and redistribute modified copies of. So free software is very much at the core of Geeks, pretty much like Debian in a way, and like a whole bunch of other distros like Triskel. Because we want free software, that also means we're providing a curated distribution. So it's not like if you want to add a package to Geeks, you have to go through a review process that goes with it. So review goes beyond just checking whether it's free or not, but that's part of it. The second thing is we're trying to build a universal package manager, which means that the world is not monolingual. There's software written in lots of languages, and you want to be able to install that software, whether it's written in Python, in Rust, in C, etc. So that's what we're working on. Pretty much like the traditional Linux distribution, like Debian, Fedora, and so forth. The last one is we're trying to build a transparent distribution. So that one is a bit more, perhaps more difficult to understand and to share among the different package manager communities. So let me explain a little bit. So I said we want to provide free software, so we also want to make sure that our users who install software via Geeks can get the source code of their software, right? So that's one thing. Being able to have some provenance tracking. There are some connections with user freedom, but also with security. Like if you want to be able to know what software you're installing, so you want to be able to have a link between the binaries you're running and the actual source code that it comes from. But to do that, we need reproducible builds. So you've probably heard of the reproducible builds effort, where many distros come together, many package managers. The idea, so it's called reproducible builds, but the idea is really to provide deterministic builds so that users can actually verify binaries, right? So the whole point is not reproducibility for the sake of reproducibility, but rather being able to provide verifiability of those binaries that we run. So what does it mean concretely for Geeks? So in Geeks, for example, we have a command that's called Geeks challenge. So let's say, so Geeks allows you to get pre-built binaries, right? So let's say you have different servers providing binaries. You want to see which one is trustworthy, whether one of them is not providing the right binaries. So you can run Geeks challenge, and it's going to tell you, look, we have, for example, OpenSSL that's different on the first server than on the second server, and your local build is the same as the first server, but different from the second server, for example. So you can compare. You can say, all right, maybe something's wrong with the second server, and same for Git and Pius and so on and so forth. So it allows you to actually challenge those binary providers. You can check whether they're really providing the right binaries, and if there's a difference, then something must be wrong, right? This is made easier by the functional model that Geeks implements, and which is inherited from Nix. So Nix pioneered the functional packaging model. And in a nutshell, it's just like, imagine you have Emacs, a package, a binary, and you're just viewing it as a function, as a pure mathematical function that takes a number of inputs, GTK, GC, make, etc. And Emacs is the result of that function. So the function is basically running configure, make install, for example. And you're defining all your packages that way, Emacs, GTK, GC, and so on and so forth. And on top of that, when you're building software with Geeks, and same with Nix, all the build is happening in an isolated environment, so with chroot, separate namespaces, and so on and so forth, such that if you look at the result, it's going to be a bit identical for everyone, because by definition we are building in an isolated environment precisely to maximize the chances that the result is going to be deterministic. All right, so that's one thing. Reproducible builds. But to have reproducible builds, you need to have something to build in the first place, right? So the next effort is called bootstrappable builds. And again, there are Geeks people inside that effort, but there are also people from different backgrounds, different projects working on these issues. So bootstrappable builds is a fancy way of saying we want to build everything from source, right? So we don't want to have binary blobs anywhere, because otherwise those are not auditable, right? So if you've heard about Reflections on Trusting Trust by Ken Thompson, that was some 40 years ago. Ken Thompson in this lecture demonstrated that you can have a compiler with a backdoor that propagates itself every time you recompile something, right? And that's the kind of issue we want to avoid, you know. And it's not just an academic exercise, right? It's not just theoretical. It can have very concrete impacts. So, for example, we know that the CIA toyed with the idea. There have been several experiments, for example, an experiment on the Rust compiler to try to introduce a backdoor and reproduce it using the Trusting Trust attack. Another experiment using Clang LLVM, for example, and exploiting this time bugs that already exist in the compiler, but it's kind of a similar attack. So it's not theoretical, it's a real software supply chain issue that needs to be solved, in our opinion. And to give an example concretely, this was the dependency graph for the first package that we built in Geeks, which is GNU-Make. It used to be that way, right? So you have GNU-Make at the top, and it depends on a whole bunch of binary blobs. So we have one big binary blob for glibc, for GCC, for binutils, etc. And this is how it used to be. But that was 250 megabytes of binaries, unauditable. So what we did is that we changed that graph to, instead of relying on a big binary blob of GCC, glibc, etc., we start from a simpler compiler. So the first compiler is called MESCC, part of the GNU MES project. And from there, we build a slightly more complicated compiler, sophisticated, TinyCC. And from there, we build GCC and so on and so forth. So the dependency graph is larger, right? But the good thing is that we've gone from 250 megabytes of opaque binary to 150 megabytes of binaries. And then we went further, again replacing other pieces of the dependency graph, such as the shell and core utilities, which allowed us to reach 60 megabytes of binaries. That's where we are today, but there is ongoing work to maybe at some point reach 0.5 megabyte of binary blobs. This is at the horizon. You can watch this FOSDEM talk by Janneke on this topic. All right, so these are the things that make me happy, you know. This is the grail for me and for the Geeks project in general. Yeah, that's the ideal. All right, but then there's real life. You have to actually provide packages, right? So recently I was working on packaging PyTorch for Geeks. So PyTorch is a neural network framework because, you know, I had colleagues needing it, so I needed to work on it. And that turned out to be kind of a nightmare for me for many different reasons. I'm sure there are people in the audience who can sympathize with that. In a nutshell, so you can find PyTorch and PyPy, but it's mostly C++ code. It has tons of bundle dependencies. It's hard to unbundle them, but we want to do that in Geeks for transparency reasons. Some things are non-deterministics and so on and so forth. So that was kind of a nightmare. But anyway, I managed, so you can now run Geeks, install Python PyTorch, and we have this wonderful dependency graph. So I was quite happy, but then I went to my colleague's office next door, who's doing AI stuff. And I said, I managed to package PyTorch for gigs. He was much less enthusiastic than myself, but so I said, how do you install PyTorch these days? He said, well, I just run pip install torch and it's very fast and it works. And indeed, it's super fast, super convenient. So it downloads 800 megabytes of archive, and then you have something that should work on most distros, maybe not on Gig system, but on most of the traditional distros. So I looked more closely into that to understand how they managed to actually provide that, that package that just works and that you can install very quickly. Because I thought that pip was a Python only package manager, but obviously PyTorch is not only written in Python. There's a lot of C++ in there. So I started diving into that. So if you download the file, the wheel archive, it's actually a zip archive that pip install downloads, and you look what's in there, you find that there are a lot of binaries, a lot of shared libraries. In particular, there are things like CUDA, which is NVIDIA's proprietary software for GPUs. And there's libgomp, which is GCC's offloading library. And that's kind of weird. You don't expect to see that in a PyTorch package, right? So I was kind of shocked, how come these things get into that? So long story short, if you look into more details, so there are several problems with that. First, you're getting non-free software, which you did not expect, right? And you're getting, the big issue is that you're getting random binaries, in the sense that you cannot verify that all these .so files actually correspond to PyTorch or to libgomp, etc. You just, it's just too hard to reproduce them and thus to verify them. And there are licensing issues. For example, for libgomp, they should be providing the corresponding source. Lots of problems. Those binaries were developer uploaded, which means that the PyTorch developers can upload directly to PyPy their binaries. Well, this is pretty brittle. Well, I spared you the details, but you can look at that blog post. The URL is at the bottom for more details. All this is convenient, but as you can see, it's pretty far from my Grail, packaging Grail. But it's worse. So Torch on PyPy is a binary-only distribution, so that's kind of a problem because you cannot verify it, like I said. But even for packages on PyPy that provide source, well, sometimes the source does not correspond to the actual upstream source. So you get a package from PyPy that contains source that's actually slightly different from the upstream source because, people can upload packages. It's not curated, it's not peer-reviewed, so, things happen. And this paper about last PyMile is precisely about that kind of issue and the supply chain security issue that can arise as a consequence. So I'm talking about PyPy, but obviously it's not just PyPy. I won't even go into the details of NPM. You've probably heard about the left pad chaos issue some years ago. There are other problems, like recently the UA parser.js package that was hijacked because, it's just, again, there's no curation on NPM, so anyone can basically upload things and you can get compromised. There are other issues like the fact that npm install actually runs arbitrary code, which resulted in a bunch of CVEs recently. Lots of problems. So that gives me an unhappy face. So I think my thesis is that all these packaging practices, so the fact that people are bundling lots of software, the fact that people are creating new package managers and also, trying to live in their own world, they mirror isolation, right? In a way, there at some point people don't want to work with too many different people. They don't want to interact with too many different people. So the easiest way, for example, is to bundle the dependencies you rely on instead of doing it the normal way, which is just to say, well, look, my package depends on some other package. And the same happens with language-specific package managers. There are many of them, and it's very nice from the language community viewpoint, because it allows you to grow the community very quickly. But the downside that we have lots of islands, basically, of different languages and tools. So the question then becomes, can we go from isolated islands to archipelagos, which means, coming together and working together? And this packaging conference is, of course, a good opportunity to look into that question. And actually, that was one of the main questions of the panel right before. So, it's my birthday next week, so I have a message, a wish list for repository maintainers. I hope it's not a message in a bottle. So how can we move forward? So I would say it would be great if repositories like PyPy, for example, would explicitly move non-free software out of the way, like in a separate repo or something, or remove it entirely. That would be my preference. But people sometimes want to use non-free software. So if at least things could be separated so people can make informed choices, that would be great. That would be a great first step. Then for PyPy specifically, I would like it if PyPy would provide always source releases, so no binary-only dist releases like we have for PyTorch. And again, disallow developer-uploaded binaries. So that was one of Debian's dirtiest secrets, in the words of the former Debian project leaders. Several years back, Debian allowed developer-uploaded binaries. That's no longer the case, I think. Because then if a developer is compromised, then you can end up distributing compromised binaries to everyone. And that's a problem. And if you do provide binaries, then it should be reproducible, verifiable. Anything else? Yes, if we look specifically at the case of Guix, but I guess if you look at other tools like Spark or apt, etc., well, the situation is similar. So today, Guix has almost 20,000 packages, and more than half of them actually come from all these language-specific repositories. So we have Rust, Python, PyPy, CRAN, Emacs Lisp, etc., etc. So if we can actually, make sure that we have a common language between those repositories and downstream package managers like Guix, then we can make great progress, I think. So in Guix, for all these tools, for example, we have a Guix import command that allows us to import and to convert the package from the upstream repository into a Guix package. So if we do that with the WebAssembly package from PyPy, we get, a Guix package. And that's great, but if we look more carefully, that one is not quite perfect. So for example, we had to modify it to add a couple of dependencies. So for example, we had to specify more dependencies so that we would be able to run the tests. We had to specify additional arguments on how to run the test, things like that. So that led me to the question, how good is the data, the metadata that we get from PyPy, from crates, and so on? So I ran a quick experiment this week by basically rerunning our Guix import command and comparing it to the packages that we actually have now in Guix proper. And the idea was to see, to what extent we had to manually modify the package definition that we imported from PyPy, from CRAN, etc. So I only grabbed, I was only able to get a few figures, but just to give you an idea. So for CRAN, for example, CRAN is very good. Like in 85% of the cases, we don't have to modify the package definition at all. Like it just works out of the box. For crates, it's kind of similar. For PyPy, it's much less. So for PyPy, we very often, like 70% of the time, we have to modify the package definition that we get from PyPy. So why is that? So the common issues that well, one issue is when the hosted source differs from the upstream source. So when PyPy gives you a source that's slightly different from what's in the upstream repository, like for example, it lacks unit tests. In some cases, of course, you have issues with missing foreign language dependencies, like Python software dependency, or you have missing test dependencies, like you need to add PyTest, stuff like that, or you have specific test procedures, and PyPy, for example, doesn't tell you how to run tests. So if I want to augment my wish list, I would say, please provide accurate package data. That's already getting better and better, but in some cases, especially PyPy, we can do much better, I think. And on top of that, it would be great to have good licensing info. That's not always the case, and even it would be perfect to have nice descriptions and synopsis. Turns out that this wish list is shared by many people. There is Microsoft, for example, I just learned, has a team working on precisely these issues on PyPy, NPM, and other repositories. And there's the executive order of the US government on improving the nation's cybersecurity. It has specific points on software supply chain issues. It's actually surprisingly technical. But people are looking into it. So to wrap up, I think package managers have become kind of a source of our supply chain issues. That's very clear in the case of NPM, for example. There have been high-profile issues, but then they're also the solution to these issues. And I think we can work together to address these issues by improving the quality of the data, and the quality of the processes that lead to those repositories. And this is it. I think I'm right on time.
All right, thanks, Ludovic. I think we do not have time for questions, so I'm going to go to the next talk. Thanks a lot. Okay, I guess actually let's do one. Let's do one question. Yep. Let's see. How did Geeks deal with PyTorch's non-free software dependency?
So currently it does not deal with PyTorch's non-free software dependencies. So the official PyTorch package in Geeks proper is CPU only, so it's not very useful for some big data sets. But I suppose people are going to create variants of that package that use CUDA, for example, or that use AMD's ROCm tools.
Okay, thanks. I'm going to kick it over to Shay. And the next talk is, let's remove Ludovic from the stream. Let's see, how Nix and NixOS get so close to perfect.
Hi, my name is Z, and today I'm going to talk about Nix and NixOS. This is my favorite Linux distribution, and it's one of my favorite tools for building software. However, it has a lot of rough edges that make it hard to learn and make it just not as perfect as it could be. In this talk, I'm going to go over a lot of what makes it great and what I'd love to see make it even better. As I said, my name is Z. I write a lot about Nix and NixOS and use it a lot personally and soon professionally. As a disclaimer, this presentation may contain opinions. These opinions are my own and not necessarily the opinion of my employer. I do not intend ill will to any people or their work in this presentation, and I want this to be better because I am passionate about these tools, and I believe that this is the best and obvious choice to do things. The QR code on the slide links to my website, Christine.website. I'll have the talk of on the website within the same day of the presentation you're watching right now. Let's start with why NixOS is great. NixOS is great because it lets you pick from cookie-cutter templates to make a server do exactly what you want. It builds on the shoulders of giants to make it easy and effective to make your servers built to purpose. As an example, here's a little NixOS module that enables Nginx and Postgres on a server. That's it. This modularity also extends to your own custom modules. I've done some write-ups on how to write these custom modules but here's an example for one. It's my Gemini server. Finally, one of the best parts of NixOS is that it makes it hard to do something the wrong way. You can't just hack up a systemd unit on the fly. You need to do it the right way in configuration management. This makes it easier for you to ensure servers aren't being tampered with without going through a review process, and so you can go back to a project in 6 months and still have some idea on how it's supposed to run on a computer. However, one of the biggest things in my book is the fact that NixOS lets you undo configuration changes. Worst case, you might need to reboot into an older config, but in general, if you mess something up, you can go back. This is a lifesaver, especially when you mess up network configuration. So this sounds great and all, but you might be thinking, there's a catch, right? There is a catch. It is hard to learn. The tooling and documentation are not the best, and they are the most important parts of the stack that you deal with when you're learning it. This is a little comic showing a rocket-powered wagon, which is kind of what NixOS can feel like at times. One of the bigger tooling issues is somewhat technical, somewhat social. Right now, the Nix universe is in the middle of switching to a new hermetic view of the world they call Flakes. Flakes has a lot of differences between classic Nix, and it makes a lot of techniques and configuration non-transferable between the two. It has effectively soft split the community between people that use Flakes and people that don't use Flakes. I personally don't use Flakes because I haven't seen good arguments as for why I should. Nix, the language, can look a bit like a combination of Haskell and Bash in ways that are kind of deceiving to people that don't have solid experience with Haskell or other functional programming languages. This is a little bit of code that breaks a host :port thing into just the port number so that you can add it to a firewall rule. Additionally, it also checks if you have TLS enabled with HTTP certification for Let's Encrypt and adds port 80 for that. But if you aren't really familiar with Haskell or other functional languages, and without the 14 plus lines of comments explaining what's going on from the place I pulled this from, it's going to be difficult to understand what's going on. Another annoying part is that Nix, the package manager, Nix, the language, and NixOS, the operating system, all have very similar names and kind of semantically override. I have created a handy diagram with a bunch of that maps out the relationships between them, and here it is. Nix, the language, is not Nix, the package manager, though Nix, the package manager, uses Nix, the language, in order to do things. Nix, the OS, is not Nix, the package manager, even though it uses Nix, the package manager, to manage packages. And NixOS, the OS, is not Nix, the language, even though NixOS uses Nix to configure itself. The overall relationship is similar to the Holy Trinity or JavaScript equality rules and can be a bit deceiving to learn at first. Another paper cut is that Nix does have a REPL so that you can hack up things quickly and so you can get to learn the language a bit better. However, the REPL can take different syntax than you can put in files. So if I want to declare a variable like foo equals bar and then use it somewhere, in the REPL I have to do foo equals bar without a semicolon or without a let. That can be very annoying at first, because you can pack up something in a REPL and then your instinct is to go and paste it into a file, but you need to edit it a little bit, and it's not entirely obvious at first. NixOS has modules to configure itself. However, these modules are only as flexible as they are written to be. If someone doesn't allow you to do a certain type of configuration to a program that's behind a NixOS module, you just can't do it without fixing the module. These sort of make them more like templates instead of functions for reaching a desired system state. However, this will get you most of the way there, but when you get into very complicated setups, it can get challenging. Adding on to this, most of the modules in the standard set that are shipped with NixOS are not documented in the NixOS module, including Nginx. There's a search site that lets you query the list of options in the standard set. However, if you're not entirely sure what you're doing, there's not always a good template to start from. When your needs change beyond what the NixOS module is doing, you can actually monkey patch it. However, you have to monkey patch the side effects of the modules rather than monkey patching the module itself. As an example of an obscure module, let's look at WeChat here. WeChat is an IRC client, it's the one I use, and NixOS has the ability to manage WeChat for you. This is all of the documentation for the WeChat module. All of these things expand out and have more detail, but these are all of the settings that you have directly. Another thing about this module is that it's great for running one instance of WeChat, but if you want to run multiple copies of it for like a community shell box, you either need to write your own NixOS module that allows you to do that, or use NixOS containers to do that, and at that point, why not use Docker? Another huge paper cut is with disclosure and vulnerability detection for security reasons. Something important for both standard production and certification is the ability to answer the question, how do I know a server is patched against a certain vulnerability? There are a lot of inherent advantages to Nix and NixOS that would make this a lot easier. However, there is not really a good way to do it, and there are not regular communications about security vulnerabilities. This can make certification difficult. Another annoying thing is backports. There are no hard rules on what is to be backported and what is not to be backported, which means that packages in stable branches likely will bit rot from what the upstream intended they would be. Most of the time, you can run NixOS unstable to work around this, but it may not be the best idea to run the unstable branch in production. Also, if you want to configure PAM to do something special, such as send a Slack message to some channel whenever someone logs into a machine or runs a sudo command, and that option is not already in the PAM options in Nix packages, you're basically doomed, because PAM is not very configurable on NixOS. The PAM modules offer you the ability to enable things like TOTP, two-factor auth, but that's about it. Another annoyance comes when you're trying to deploy software on a production cluster using Nix itself. There's not really a good tool in the standard Nix toolset for this, but there are tools like NixOps and Morph, and these allow you to describe the state of your entire fleet of computers with the same NixOS module syntax that you use for local machines. However, the documentation for these is lacking. NixOps does have a fairly decent manual, and the documentation for Morph is a bunch of example configuration files. I have a little screenshot of part of my Morph configuration for my home lab. This manages the NixOS machine under my desk. There are other options using NixOS and Morph, however, these are the more Nix native approaches to do it. Because NixOps and Morph aren't very documented, it makes it an annoying catch-22 situation where learning NixOps and Morph requires you to already know how NixOps and Morph work, which can make it hard to get started from scratch. This is part of the reason why I make all of my NixOS configs public on GitHub, so that people have something to go off of when they're trying to figure out how to do more complicated things. Without publishing my configs on GitHub, I would be afraid that people would get incredibly lost like I was when I was trying to figure it all out. As an example of things that just got me totally lost, let's talk about keys. NixOps and Morph use the term key where other ecosystems would use the term secret. They basically allow you to have values that aren't managed in your Git repo for things like database credentials, AWS credentials, or other API keys. And normally you want to have things so that this service, for example, a service that I wrote for myself called Me, depends on the keys for it being started. In NixOps and Morph, what you're supposed to do is you're supposed to make a secret for that. It will create a systemd service, and then you sequence the systemd job to start after the key. However, the documentation doesn't really make it clear on how to do this, and I had to figure this out by searching GitHub for NixOS code, praying someone already figured it out and made it open source. Another annoyance is that you can't pull values from other machines in your cluster. If you have a VPN with a dynamic IP address and you want to pull that IP address to use in various bits of configuration, you're going to have to hard code it somewhere, which means that it's a bit more difficult to do things dynamically. In comparison, when using something like Ansible, it is trivial to pull this information off of a machine with its FACT system. Finally, let's talk about what I think could make all of this better, easier to learn, and a much more obvious choice for production. These are my ideas. They may not entirely work in the real world, but in an ideal world, this is what I'd love to see. First of all is I would love to see the documentation being the strongest part of the NixOS ecosystem. Documentation is the difference between understanding something and not understanding something. You generally have to understand something to be able to use it productively. In general, the standard documentation should cover how to get started, what you can do, and detailed documentation on every single thing that ships with NixOS by default. There should be no module in the library of modules without documentation on how to use it and an example or two of where you'd use some of the weirder options. Error messages are also critical for understanding what's going on. Here is an example of an error message that I have encountered in Nix and NixOS a lot of times that just has utterly baffled me every time. No, adding the show trace flag does not show more detailed location information. In this case, I got it by sequencing a package import in the wrong place in a way that didn't seem obvious to me, but without better error messages, you just have no idea what's going on. Let's consider some examples of better error messages I've seen around in other projects. Here's Rust and Elm. In this case, Rust is saying that I don't know what you're doing with this value. You're trying to return something from an if statement, but then you're just totally ignoring it. And in Elm, list.nap is used in place of list.map. In both of them, the compiler tries to work with you to help you figure out what went wrong. Another great thing about what Rust does is that it has error codes that you can Google for when you have something going wrong, so that you can more easily understand what you're doing wrong and how to learn how to not do it wrong in the future. This is being worked on. Here's an example of what the better error messages look like. I just wish this was here sooner. Another way that things could get a lot better is by taking advantage of language-specific package managers to automatically figure out what to do instead of having to fight them against what they are doing. There are tools that automate this, but ideally I'd like to see this just automatically happen using import from derivation or something like that. As it is right now, packaging things like Go, Node, and other things are really iterative and annoyingly non-trivial. Maybe it would be better to have modules act kind of more like functions than templates. It would be nice to have modules return something that you can splice into your configuration instead of the modules being enabling something into your configuration, so that you can manually monkey patch things and run multiple instances of a service if you wanted to. You can work around this like I mentioned, but it would be better if this was a native solution. And that about wraps it up. NixOS is actually pretty great. It's just really frustrating to get started with. I really wish it was easier, but right now it just isn't. If you have any questions about this talk, please feel free to ping me on Twitter or on the contact or some contact method on my website. I love answering these questions. I'll stick around in the chat for a bit and answer questions if you want to ask them there. Thank you. Stay safe and be well.
Okay, thanks. I'm going to add Z to the stream, and I think we have time for a couple questions live. So here we go. Here's Z. Are you there, Z?
Yep, I'm here.
Okay, awesome. So I guess, let's see. I think you've already answered some of these in the chat. I had one on importing language-specific package manager packages. A lot of those do dependency resolution with a solver. Are there challenges to integrating something that does that into Nix, which basically has humans as the solver managing the repo?
Actually, I have kind of a hot take opinion here, but I think that we should just take the output of the Nix out of the language-specific package manager solver and import that into Nix. because if you don't do that, then things are going to get very confusing for like the upstream maintainers when they're trying to find a bug, because they would expect the one solver that npm or Go uses to be the thing that is actually shipped.
Sure. Okay, I like that take, actually. I think that's cool. That's like importing a lock file version of something.
Yeah, that's what the import from derivation stuff I mentioned was. In the case of like Rust stuff, it'll literally walk over the cargo.lock and turn it into a bunch of Nix instructions to grab the things that Rust concluded was the right thing to do.
What about when the ecosystem solver doesn't manage certain things in, say, the Nix ecosystem, like lower level libraries and stuff like that?
That's going to be a problem no matter what you do, but you can get pretty darn close. And most of the time when those language-specific package managers can't find a native dependency, they will explode loud and angrily. And usually the explosion has enough detail to go off of.
Okay, cool. I'm not seeing too many other questions in the chat. I guess, do you want to do this one live? Did you try to improve the lacking documentation? What was the blocking point you faced during the process? Any comments you want to say live on that one?
Apparently, at the time when I tried to improve the documentation, it was all in DocBook, and I am apparently quite terrible at editing DocBook. But now it's Markdown, so I can probably do it a bit better.
Awesome. What is your take on secrets or things that you don't want in the store? From Fareed.
That is actually a surprisingly complicated topic. I thought it would be easy, just like make sure that the files get there somehow. But then comes the bootstrapping problem of if you just put the files in like /run, like NixOps wants to do, then when you reboot, the entire system is stalled waiting for the secrets to be manually deployed. I think the ultimate solution is probably something like the AWS Buzzword or HashiCorp Vault, but it's a surprisingly complicated problem. I personally get around it for my stuff by using Age to encrypt things for the machine's SSH host key, and then I will have a bunch of systemd jobs decrypt things and put things in the right places so that the decrypted configuration file is there before the encrypted configuration file is there before the underlying job starts.
Okay. All right. Well, I think we should get back on schedule. Thanks for having a slightly shorter talk to allow us to do that. And I thought that was a really great talk. Let's add Wolf and Z will be in the chat too, folks. So here, I'm going to put Wolf in here.
All right. Yeah, so I'm here to tell you guys a bit more about Conda Forge and the Mamba project, and especially the libmamba project, which I hope is useful. So just to give a bunch of quick introduction words about the Conda ecosystem. A lot of people know it historically for Python or data science, but it's not actually only that. It's a general purpose package management on top of like a different host system, basically. And in the Conda ecosystem, like both Conda and Mamba, so Conda is the like older package manager and Mamba is a bit of a newer reimplementation. And they're both using a SAT solver for package resolution, but different ones. And in the Conda ecosystem is completely cross-platform, so it works with Windows, Mac, and Linux, and it's also language agnostic, so it's not Python specific. There are binary packages, and it's also build system agnostic, so you can use CMake, AutoTools, etc., etc. And so basically the tagline here is Linux-style packaging for everyone, so that people on Windows and Mac can also enjoy the same kind of nice package managers that we have with apt or DNF. And now Mamba is, as I briefly mentioned, a fast Conda compatible package manager. So it works with all the Conda packages out there. Specifically, Conda Forge or BioConda are two very large channels that are very well supported and ship a lot of bleeding edge scientific software. It works on Linux, macOS, and Windows, as I already said, and it's implemented in C++ for speed. and it natively supports virtual environments and licensed under BSD3. I'm also part of the Conda Forge project, and I want to speak about that a bit as well, because I think it's in the interest of this conference. So Conda Forge is the largest channel for Conda packages by number of packages. It's a public collection of recipes. Recipes are like the build scripts and metadata for packages on Windows, Mac OS, and Linux. And then on Mac OS, we have for the M1 and the old x64, and Linux, we have packages for Arch64, x64, and PPC 64LE. There are over 3,300 individual contributors and 25 steering committee members, so it's a very large project. And there are over like around 15,000 libraries that we are shipping in many different versions, which totals 700,000 something packages, a bit over 3.6 terabytes, and over 300 million monthly downloads. And one cool thing is that it's almost entirely run on public infrastructure, so we are using GitHub and Azure to a crazy extent. And another thing is that artifacts are never deleted, which gives us reproducibility. So you can recreate the same environment in 10 years with the same packages, and hopefully it will still work. This is a chart of the growth of Conda Forge. So here in blue, you see the Conda Forge channel in download count. It's really like kind of an exponential growth here. And we've recently overtaken the defaults channel from Anaconda. And there's also BioConda, which is also growing quite a lot. So that's really cool, because those are two really successful open source projects. And I want to kind of put Conda Forge somewhere between a Linux distro and PyPI. So with a Linux distro, I would say you have usually solid and established packaging. You have a few members that are basically quality control and gatekeeping a bit, which makes it slower to update, but usually the quality, let's say, it's pretty good. On the opposite side, you have PyPI or NPM, where there are basically no real quality checks, because everybody can just upload their own packages and publish them. And yeah, you have a member per package. In Conda Forge, we have Conda Forge Core, which can and does do some quality checks. But we also have really a lot of members, and they have independent feedstocks. A feedstock is a Git repository where they can just like change the recipe, and once they merge a pull request, which they can do independently, the package will be published to the channel. So it's more free in that sense. So how Conda Forge operates: we have a staged recipe repository where we check the initial recipe quality and make sure that it's actually building. And then once the recipe is merged, a feedstock, which is a Git repository on GitHub, is created. And then we run automatic builds on public CI for all the different platforms that we support, and that are supported by the recipe. The maintainer controls the release schedule for this library. We have admin bots and other bots for general feedstock maintenance tasks. And we also have automated version bumps from the bot. They are automatically detected. GitHub, PyPI, and URL schemes are checked. We have automated migrations because Conda Forge is a rolling distribution. So if one library like OpenSSL changes, then all the packages that depend on OpenSSL will be automatically rebuilt. And we have help via GitHub issues and the GitHub chat. Example software on Conda Forge, all kinds of stuff: C, C++, Python, R, Julia, Qt Toolkit, OpenCV, GCC, HDF5, everything you can imagine. And we actually want everything. So what is a recipe? A recipe is mostly static YAML with some Jinja and a build script that's usually Bash or CMD on Windows. It supports cross-compilation with like build, host, and run environments for where the host environment can be of a different target platform. And dependencies can be easily constrained. And so Conda Forge is kind of a huge repository of mostly static information about all sorts of packages and also older versions, as in a way it's kind of a Wikipedia-style knowledge base of all software. And I hope we can go further in that direction. So this is what a recipe looks like. So you have a source section here, which gives you URL and char for the source code, version and package name, some build number, and then the requirements. And here they're not really constrained, but usually you would probably see some constraints. How do virtual environments work with Conda or Mamba? So they work just like a regular, normal Unix-style prefix. So you have these kind of standard folders over here. And then files are mostly hard linked from a shared package cache in a packages folder. So that means that if you have multiple virtual environments, the files are actually shared, so you don't really have copies of them. And then files are copied if the prefix needs to be replaced, which sometimes happens. And that's how we make packages relocatable. Now I want to talk a bit about Mamba and the parts and how they can be reused. So we're using libarchive for extracting packages, libcurl for downloading data, libsolve for solving the dependencies, OpenSSL for cryptographic verification. And then some other libraries, and Loma.json, YAML-CPP, and Speedlog for logging. We also support bootstrapping with another tool called Micromamba. Micromamba is completely statically linked, has 0 external dependencies, and uses the host SSL certificates. Compressed to tarbz2, it's roughly 5 megabytes. Extracted is around 12 megabytes on Linux, a bit less on Windows and Mac because there we use more of the host SDK libraries. It almost has feature parity with Mamba, and you don't need to be root on the computer that you're using it to install new packages, which is a pretty nice feature. I want to talk about package formats because I think that's, for example, a lesson that was learned by the Conda ecosystem. So the old default is tarbz2, but it's slow to extract and also slow to index on the servers. The new format is .conda, which hasn't really gotten everywhere yet, but hopefully we can work on that in the future. The benefits are that it uses ZSTD for inner compression. So you have 2 folders actually that are compressed inside. One contains the metadata and one contains the content of the package. And it uses an uncompressed zip as outer layer. So the metadata is split off to make it faster for indexing. A tool that I'm currently working on that I'm excited to share is called, currently working title is PowerLoader for fast down and upload. It's very much inspired by another library that was Linux only that's called librepo, which is used in DNF. It features things like parallel downloads, mirrors and automatic mirror selection, retries and fallbacks to other mirrors, automatic checksum validation, resumable downloads, and zchunk and delta transfers, so that you only download the new parts of a file. And it supports HTTP, FTP, OCI registries, and S3 mirrors, which I'm pretty excited about. Because basically all these GitLab, GitHub, they all have OCI registries. And it also supports uploading to HTTP, S3, and OCI. We still need to work on it. It's kind of in an alpha state right now. We're also using libsolve, which is a really cool library for fast SAT solving. It's quite good speed improvement over the Conda solver. And it's a pretty efficient backtracking solver. And we make use of it also for variant packages. And we can prefer certain variants. And it's almost 100% compatible with the legacy kind of Conda solver. And actually, the solver that Mamba uses is currently being integrated back into Conda and will hopefully ship with an experimental flag soon. libmamba is Mamba without the command line interface. It has C and C++ bindings, so you can easily reuse it. And it can actually be used to create language-specific package managers. So we've written one that's called Ramba, and which is a package manager for, or in R, actually, that works similar to the R native package manager. And then we also have libmamba.py, which we are currently in the process of splitting off, which is the Python bindings to libmamba. I also briefly want to say a bit more about package signing, which is something we've implemented in this year, and it was a lot of work. So package signing is using OpenSSL for key signature verification, and it's based on the update framework and the Conda Content Trust work. And we basically put signatures into the repo data JSON, and it's modeled after the Tufte update framework. So we have stuff like a root role, key manager role, and package manager role. And the process to sign is something we're currently working or thinking about a lot. So one option is to sign with an online key that's on the server. That's very easy. But we would also like to figure out ways to sign with an offline key. So give the package maintainer the artifact unsigned, and then the package manager can sign it with his key. Or we can also figure out if we can produce signatures beforehand, and then the package maintainer uploads the signature, and then it gets built in the CI services. But that's pretty difficult because then the package maintainer has a lot of work, and it's only really possible if we support reproducible builds. Here you can kind of see how this is working. So Quetz is the package server that we are working on, and that has signature data that delivers signature data in the repo data JSON, and also has tough roles that can delegate further down. So you have an entire security chain with a root role and like multiple other delegations. There's a blog post coming out about package signing pretty soon. We're also looking into Sigstore and other initiatives that are really well funded, and we're trying to figure out if there are ways how we can reuse this for signing these Conda packages. I think that would be great because setting all this infrastructure up and so is a huge task. And if we could share that with another community, that would be pretty great. And we'd also like to figure out better how we can do identity management, and we'd really like to leverage GitHub because Conda Forge is already operating on GitHub a lot. So one idea that I also wanted to present and that I hope we can solve at some point with like libmamba and these initiatives is that we have a bunch of applications like FreeCAD, QGIS, Blender that use, for example, Python as an extension language or a plugin language, but they don't they have kind of homegrown solutions on how to do plugin management. And it works kind of like sometimes with calling into pip or installing a zip file from somewhere or something like this. But they all have like there are some limitations. And it's kind of my belief that if we could give them libmamba, they could have their own package repository or reuse one that already exists, and then have an easy way to manage plugins that work with the underlying application, and that also like can ship native code, can ship code from many different programming languages all natively, and also have, for example, interdependencies and stuff like this. So I think that would be really cool. And there was also really quite strong interest, at least from the FreeCAD and QGIS communities, to go into that direction. So I hope we can explore that further soon. I just want to quickly talk about other pieces in the Mamba org. So I already briefly mentioned Quetz, which is an open source, easy to deploy package server. And code is based on FastAPI, a Python library. It's storage agnostic. So you can use S3, Azure, Google Cloud Storage, and hopefully soon OCI as well to push the packages to. We have pluggable authentication. You can, and a bunch of implementations already. Fast searching for packages, and it's really extensible with plugins, both in the front and the back end, which is pretty cool. And then we are also working on a tool called Boa, which is a build tool for Conda packages that comes with an improved recipe format, which is like more pure YAML and doesn't have Jinja, because Jinja makes YAML not really parsable anymore. We are also trying to improve cross-compilation further and enable WASM support. So compiling all the Conda Forge packages to WASM would be really cool. And we have an experimental interactive mode, or REPL, where you can kind of debug the package build, which was a bit inspired by Binary Builder JL, which I find pretty cool. And for next year, we're also trying to have more reproducible packages and figure out stuff like deleting timestamps before we archive the files and stuff. In 2021, we got some funding from the CZI grant that we won. And one thing that we really want to do is improve solver messaging further. So libsolv already has pretty nice solver error messages, but we want to really look at the pubgrab projects, and I'm really keen to see the pubgrab talk and see if that improves solver messages. and we want to see how far we can use that or implement that into libsolve. We'd also like to look at how we can further sandbox virtual environments, because currently, like containers are nice because they're more sandboxed from the host system. Virtual environments are also nice. But maybe there's a way to create kind of ad hoc containers for these virtual environments. And I know that Windows and Mac OS have pretty good sandboxes, and Linux and Flatpak also has them. And we want to parallelize everything more, make it faster. And we also want to improve the server story, store source code for all the recipes out there, and make builds more reproducible. And then finally roll out the package and repo data signing to CondaForge, because right now we have the implementation in Mamba, but it's not rolled out anywhere. And that's it. Thanks. And if there are any questions, I'd be more than happy to take them.
The chat, there were a few. So one of mine was, to what extent is CondaForge more or less like a Wikipedia of all software than, say, Nix Geeks, Debian, SPAC, or any other package ecosystem?
So one thing that I've seen in other packaging ecosystems is that the metadata might not be so machine readable or parsable or like not so static. Mm-hmm. What I really think we should be doing is have some part of the metadata as static as possible. And yeah, I think YAML, for example, is a good format for that, because it's not a programming language, which I've seen in some other, like some metadata use, some package managers use, for example, Python for this data. And I don't think that's the appropriate choice.
Okay. All right. Next question. Are .conda files going to be the default on CondaForge at some point? I have yet to see one in the wild, but maybe I'm just oblivious.
So they are actually already shipped on the Anaconda channels, but not on CondaForge. That's right. One reason for that is backwards compatibility, I think, or it would also take quite a bit of energy in terms of CPU cycles to convert all of them. But yeah, like I would love to tackle this soon, because they are actually great and a major improvement.
Okay. What's better about Rumba versus the R native package manager?
Probably nothing, but it was a cool experience.
Okay.
And like, if you want to interact with Python packages or C++ packages, you know, you probably don't get that from the R native package manager.
Okay, so that's a good. So I mean, is the idea that it allows, you know, more easy interaction with native package managers? And it obviously is doing solving. Is the solving better than the R native package manager?
To be honest, I don't properly know how the R native package manager solves dependencies. Okay. But like, if you have a C++ dependency, for example, maybe our native package manager on Linux would install you like Boost or something from APT. But how does it do that on Windows, you know? Mm-hmm. So if your R package needs Boost, and one other thing that's actually an improvement is I think the R packages are usually not compiled, at least back in the days. And so usually they are compiled, and we actually ship binaries. So you have a binary package manager, which is much faster than, you know, using the CRAN packages and have to compile them locally.
Okay, there was another question I think partially got answered in the chat, but I'm going to do it live too. I saw that Conda package support was integrated into libsolve at some point. Is libsolve extensible enough that you could use it for Mamba before Conda support was upstreamed? I think what that means is that, so I thought the extension to libsolve was like to support the Conda package format. Isn't that
so?
Right?
libsolve themselves, like the author of libsolve actually wrote the initial, like the initial support for Conda metadata format, yeah, libsolve is extensible to some extent, yeah, but I'm not sure if I like the second part of the question. I mean, so
I think what he's asking is like, could you just take libsolve and use it for Conda without whatever contribution was made to the library? Is it general enough for that, or do you have to have an adapter?
Yeah, you could. Like, you can actually read like the repo data JSON file directly with libsolve and then do stuff with libsolve if you want.
Okay.
I think it's better to use libmamba because we ship all the wrappers and like the niceties around it. But
Okay, and how to handle the growing number of PRs in Conda Forge staged recipes?
yeah, that's a tough question. I think we could like everybody can apply to become a staged recipes maintainer or a core maintainer, and then there is a vote. And if the existing core team trusts that person, then yeah, and we'd love to onboard more people to do these roles in the community.
So I don't know how it works for Conda Forge, but like for SPAC, I mean, we have a single recipe per package, and everyone sort of contributes to it. So the PRs, we did have a problem that maintainers weren't getting notified about changes to the packages, and so we made a bot that basically pings them. Is that something that Conda Forge does?
No, in Conda Forge you get a completely independent feedstock, which is a completely independent GitHub repository. And if I make a PR to staged recipes, like the maintainers of staged recipes or the core maintainers look at it, and if it's good, they merge it. And once it merged, there's an automatic process to create a new, fresh Git repository where you will be added as a maintainer, and you have full right, like you can do anything.
All right. And I think that's all the questions for now. I guess I can ask another question since we have like 2 more minutes. You know I can ask questions all day. So for libsolve, you said you're looking at sort of modifying the error messages. I haven't dug into libsolve enough to look at the API. How extensible is it? How much control do you have over the solver? Like, is it easy to add like a new feature to libsolve if you wanted to add a new, I don't know, support for features, support for optional dependencies, support for something to it? How easy is it to modify?
It's pretty tough C code, like libsolve itself. So it's not straightforward to modify the solver as such, I would say. I think like you can do some cool tricks, I think, with like how you structure your packages and dependencies and stuff. But yeah, there are definitely areas that we also need to explore in the libsolve code base, and it's like kind of a research and development project to figure out how we can get better error messages out of libsolve. But I think it basically, like, for all it does, like it will record like what packages had incompatibilities, and I'd like to look at this record of incompatibilities that libsolve finds and see if we can somehow like use all the information that's there to actually get to better error messages. But I cannot yet say how and if it's going to work. And we'll definitely try to use pubgrub RS and to make it read Conda repo data, and we'll see how well that works and what kind of error messages we get out of that.
Okay, I have a long question to that effect also, which is sometimes this is like, it doesn't fit in one thing, but it's sometimes when solving large environments, there can be a single old package that forces the whole environment in some direction, like to use an older version of Python. Are you planning on including solver warnings and logs that would let the user know why certain solve decisions are done?
We do have an open issue to that effect, and I would love to figure something out, but it's hard to figure out the user's intent basically sometimes. So yeah, like some warnings I think would be appropriate for certain circumstances. Yeah.
And do you think that that's straightforward? I mean, like how easy is it to understand the chain of reasons for an unsat case in libsolve?
I mean, for example, in this case, if you don't specify the version of Python that you want, but you get like an older version as the latest Python that exists, like we can just check what's the latest version of Python and then tell you, okay, for some reason you only got Python 3.6, but actually Python 3.9 is already available. Maybe you can figure out. And then, I mean, we could also probably show like what package is constraining that. And we do have like kind of implementations for doing like, we copied that from DNF, which is like a repo query command, where we can show all the reverse dependencies or the dependencies of given packages and this kind of stuff.
Okay, I have one last question, and then we'll go to the break and resume. It's 20 after. Your talk was too short, so you have time for all these questions. So the SAT community and SMT and all the related areas, they have benchmark competitions where they look at solver speed. And I'm kind of thinking that it might be time for us to have something like that for package managers. What do you think of that idea? Do we have enough example cases? Yeah, we should.
I have to say, like, I'm not the major contributor to libsolv for sure. So like, I'm not even contributing a lot. Like, most of the code was written by Michael Schröder.
Yeah.
So
are you looking for someone to take on the mantle of that libsolv guy for package managers that are not?
I mean, it would be awesome to find more people to actually hack on libsolv. Yeah, for sure.
Yeah. Cool. Okay. I think we're going to take a short break, and I will put on Sebastian at 20 after, which is when he will talk about the Fortran package manager. So I'm just going to put this up there for now, and we will start in 2 minutes.
All right. Then let's start. So today I'm going to have it out our project for the Fortran Package Manager, which we are trying to build to get toward a rich ecosystem of Fortran packages. So I'm Sebastian, presenting this joint work of a group of volunteers at the Fortran Latin community. You can find us on GitHub at Fortran Lang. So the 3 points I want to talk about today is why we want to have a package manager for a language like Fortran, how we implemented our package manager, how far we got already, and a bit of outlook where we want to go. So maybe I should start this talk by explaining what Fortran actually is. Because maybe it's not that well known anymore, but Fortran is in fact the first high-level optimized cross-platform programming language, and it was developed by John Barker's team at IBM in 1954. So this is quite an old programming language, actually, I think older than C and languages like Lisp. And it was originally created to ease the translation of mathematical formulas directly into machine code. And it has been and is still very successful in the scientific computing community. So many scientific applications libraries are developed in Fortran. And the language is still under active development, with the latest standard being 2018. So our motivation to build for an existing language a package manager is that building and distributing Fortran software is difficult. It's not impossible to do it with other strategies. Many build systems do support Fortran, and there's CMake, there's Meson, AutoConf, which you get to work, but most Fortran developers are actually more scientists rather than really familiar with all those tool chains. And sometimes writing of those build files and adjustments for Fortran can be quite time intensive, and this makes it somewhat difficult or tedious to reuse Fortran source code. The other issue which we have in the Fortran ecosystem is that system-wide installation are a bit dangerous if you're using multiple Fortran compilers, and most Fortran developers are using at least 2 or 3 compilers for their projects, because there's no real ABI compatibility between different Fortran compilers, which made it in the past somewhat impossible to depend on a project without redistributing it, which makes it is not quite a good thing to have. So we decided we want to have a Fortran-specific build system and package manager to fix this, to make it easy to create and distribute reusable Fortran libraries, which we started with this project, FPM. So we can consider this primary build system and productivity tool for developing Fortran. And some of the challenges about Fortran is that we have modules which we are using to share symbols between packages and source files. And we have those since Fortran 90. C++ added those in, I think, C++ 20. And Fortran also had something like submodules, which allow to provide implementations. And due to these models, we don't really have header files, but those modules are how are the interdependencies between our source files we need for the compilation order. And to make the information about the symbols available, you have to install these module files. But since we don't have AB compatibility and no standardized module format, you have to make sure that the compiler doesn't pick up the module files from a different compiler. So these are the constraints we have to look into for building a Fortran build system which takes care of this. Usually most build systems are not really tailored for this challenge. So one thing to do was like selecting a language to implement our package manager. And one of our aims was to find something which is fast, which often not overhead. So usually we look for a compiled language here. It should be self-contained and simple to set up. So preferably a small runtime library or static binaries. And we wanted actually to make it easily accessible for our users to contribute back, which are mostly Fortran developers. Since most Fortran developers are familiar with Python and C++ as well, those are obvious choices. Python doesn't really qualify for being that fast, and maybe not also easy to set up. So we want, looking more into compiled languages, we started drawing some inspiration from Rust and Cargo. So we started implementing our first prototype in Rust, and at some point switched to Haskell for implementing. But both two languages in our community have the problem that we don't have many developers familiar with this. So in the end, we decided to actually implement our package manager in Fortran, because it's the most well-known language in our community, and compilers can easily produce static binaries for our distribution. And Well, Fortran has been around for a while. There's not really wasn't really a community around actively developing the tooling, but more individual library developing. And we want to use this opportunity building package manager, building a large standard library, and trying to improve in this process the language and our tooling. So, of course, building a language package manager means that we are building the package manager with itself, and which makes a lot of sense since we're writing it in Fortran and we're using it as Fortran package manager. Building it with a Fortran compiler would be the only thing the user for sure has available on their system. And we could boil it down for minimal dependencies requiring only a Fortran compiler to build it from a single source code, which you just download by some means, maybe called an compiler review, Fortran compiler of choice, and then use this binary to bootstrap the installation, which then requires a bit more because we want to interface with some C libraries, and maybe need to fetch dependencies, which you're currently doing via Git. So how far is our community with building those? Our compiler interface currently features a couple of things one expects in a package manager, like we are able to build a Fortran project which follows our standard layout for handling modules and submodule interdependencies, automatically finding all our executables and tests. Then, and of course, we can just directly run our Fortran project out of the source. Again, with something which you would expect, you can make a selection, use globbing. Of course, software projects have to be tested. Fortran is no exception there, so we provide easy integration with unit tests to find and run test executables, allow them to run them in a debugger. And of course, if this all works, projects can be installed. And we follow this strategy like it came up with NPM. We install a user prefix by default. And to make sure users get easily into our package structure, we provide a command to actually create new projects and also backfill existing projects with our layout. And then, of course, we have a dependency management, which was updating and building a basic caching logging. So our inspiration was mainly taken from Cargo. So we went with using a package manifest in Toml, which is to limit the complexity of the build files and only contain mainly metadata of the projects. We impose a default layout, which allows FPM to automatically find everything, and but give the user the possibility to customize this to their liking. We can automatically draw our names for the executables if there are multiple from the respective program units we find in the source, and of course we can link system libraries. And one thing which was important for us is we want to have first-class dependencies, which is which also help with the issue, which kind of solve the issue of the RB compatibility we have with Fortran. And right now we're specifying our dependencies to reference other projects, like a Git URL, and we provide different scopes to set dependencies for development or for just a single executable. And finally, since probably we are far from perfect with our starting our effort on this package manager, we allow to customize plugins to make it easy to stage new features. And we try to pick them automatically up from the command line and pass through all the options we got. And so far, we got a few features. So one is currently for staging our registry, which we're trying to build. Allows us to download registry data, search for packages, and include in the manifest. And other thing is mainly for documentation. Some of you might know the Linux man command for manual pages, and what we built into FPM with a plugin was the documentation for all the intrinsic commands we get in Fortran. So from your build system, you can just check the documentation of everything without leaving looking somewhere else. So FPM is kind of new, given the languages has been around for a while, and we started this effort in last year in May with our Rust prototype, which we then around the FortranCon in June switched for the Haskell implementation. And we quickly realized that while Haskell is working nicely, we didn't have enough developers to actually follow up on this. So with the first release, which I marked here in the graph, we switched to a Fortran implementation, and this gave us some traction in the community, and we are now at 200 open source projects already using FPM. And I checked most of them, so we're still a pretty small ecosystem, so I'm able to check all of them. And there are like 170 unique developers who contributed there, so not all from the same person. FPM for up to now has 62 contributors, and we have code contributions from 21 developers up to now, and we are hosting it on GitHub in a T-license project. And one thing we try to do is to be compatible with package managers, so from the very beginning. So we are already available in Spark, we are CondaForge, available on Windows and the MSys2. I'm hosting a homebrew tab to distribute FPM as well. So this is where we stand with our project for building Fortran, the Fortran Package Manager. And so, of course, at this point, it's a very early stage for us actually developing this tool. We are still looking into a good way to create a registry for all our Fortran packages where we don't have to reinvent everything, but use existing tooling. And also, one thing that is important is we want to integrate from the very beginning with other packaging ecosystems. So making it more like a productivity tool, which allows you to build your software and then easily integrate with and allow to distribute the software via Conda. Another thing, since we have a lot of Fortran compilers, we want to have also provide some very fine-grained control over compiler options, so users get the possibility to optimize their packages for the respective compilers. And we are still looking into how to best support optional dependencies and variants in Fortran with this tooling. And with this, I want to close. If you're interested in our Fortran community, visit us at any of those sites. And I'm happy to answer your questions.
Okay. I guess, let's see. I don't see any questions in the chat. If I'm missing some, then folks ought to paste it. Let's see.
Yes,
so I guess I have a question, which is, yeah, there's a lot of people talking about the last talk still. So I guess I have a question. What kind of solver does FPM use internally how does it do dependency resolution?
So right now, we haven't really explored how to deal with registries yet. And of course, we don't want to write our own solver in Fortran, but use something that we know is working. And I think maybe a good choice would be to look into libmamba. Maybe we are able to interface this easily because Fortran quite straightforwardly binds to C, which would allow us to leverage a lot of knowledge which is already there.
Okay, thanks. Let's see. I mean, are there any special semantics that you would have to deal with Fortran packages that aren't really dealt with by libmamba right now?
Yeah, main issue is probably that we have to deal with the Fortran IB issues. So, so just to make sure that we are not able to mix different Fortran packages compiled with different compilers to keep those cleanly separated.
Mm-hmm. And I guess are there a lot of Fortran packages that depend on C libraries and other sorts of things? And what's the strategy for integrating those into FPM?
So for one thing, we can actually build C. So if you would, you can use FPM as a C package manager, and we are also able to build C++. So in principle, it could be abused as a C or C++ package manager, but we don't really want to port the whole world into the FPM ecosystem. So we are looking into a way to seamlessly integrate with something other build systems and get a way to maybe just build a CMake project or depend on the system package.
Okay, let's see. There are some actual questions in the chat now. Put one in here. All right. Vis-a-vis Fortran packages, I'm looking at your package index, and I do not see some of the ones that I sometimes have to use, like IRA and AnyQuick and IGRF. Did I miss it, or have they not been ported?
Yeah, we just started. Not all packages are yet available with FPM, so we have around 200 now. But porting a big library to a new build system is kind of a difficult task. And if they have something that works, AutoTools or CMake, they're probably happy with this. So we're more looking into also supporting in that way. Or maybe getting the capabilities for FPM to actually generate those CMake files that the project can use FPM, but they stay with their original build system as well.
Okay, I guess I have, yeah, so on that question, you don't have to use FPM's prescribed build system for FPM? What do you do if you're a project that has a legacy build system? How do you typically maintain, how do you move to FPM, or how do you support it?
So one thing we want for FPM is just to have it work out of the box. So if it has the layout, the right layout, you just put the name of the project in, then it compiles. Then of course you have to check if you have to link libraries and stuff like this. We are looking into a way to automatically generate a full CMake build system following some CMake best practice for Fortran projects, which makes it easy to reuse from non-FPM projects, and maybe also easier to integrate with existing package managers rather than having to integrate add something for these package managers to actually understand and drive FPM.
Mm-hmm.
Okay. We're really open for ideas and inputs on this.
And then I guess, okay, so we're out of questions in the chat. I'll just keep asking stuff because I'm curious from the stack perspective. How are you so you don't currently allow people to mix compilers. What is the compiler model for FPM? Like, do you pick a tool chain up front, sort of like Conan, or what's the model there? How do you pick a compiler?
So what we're currently doing is, if you give us a compiler, we're going to kind of namespace the build we're doing for this compiler. And if you're changing it, this is going to change the namespace of this build. So if you can seamlessly switch between a compiler if you're specifying it with FPM. as long as you're in FPM, of course, this is not a problem. But after you're installing it, then we have to deal with this. So in most cases, if you're developing an application, this is nice and easy. If we're developing a library, there has to be a model to distinguish this. But the unfortunate thing is, unfortunately, it's on the same level as C. So we're not sure yet how we can maybe install a system prefix for two different Fortran compilers and then maybe mix this.
Does it, so does it use separate directories for each different
Yes.
build of a package, or is it okay? And
so we
what
can
about,
separate compilers.
Go ahead. Mm-hmm.
But
So okay,
of course,
but
after we install, yeah.
Go ahead.
So
So I have another question about runtime.
Okay.
Oh, go ahead. Sorry, there's a lag. I'm going to shut up. You finish the question, the comment.
Yeah, and just after we're installing the system prefix, this information is unfortunately lost. But I don't know if there is a way to actually do this.
Okay. So I guess someone is asking, how does FPM handle third-party code dependencies? So I assume it's doing some dependency management, but you did say that it's not doing solving yet. So do you have dependencies in FPM right now?
We have some very rudimentary dependencies where we're depending on Git repositories and using the Git hash information for managing. We don't really have solving. We can link against system libraries, but we need to do more in this direction.
Okay, and I have a follow-up question on that. Okay, so if you can link against system libraries, what is a system library? How do you draw that line? And moreover, with the different compilers, what about things like compiler runtime libraries? So like if you do GPU offload or if you do OpenMP with Fortran, there are a lot of libraries that come into play that can even be conflicting between multiple builds by the same compiler. So how do you answer those questions? Like how do you deal with system libraries and compiler runtime libraries?
Yeah, for one, we currently kind of relying on the compiler wrapper around the linkers, handling most of the stuff. If it comes to linking specific libraries, we don't really have a solution yet for this.
Okay. Any last comments or questions? I think that's all we've got from Element. So thanks a lot. This is a really cool project, and thanks for presenting. We will be back here at, let's see, so it's 10:44 here now. I think 11:30 is when the next session is, so that's 7:30 p.m. UTC. And the next talk will be Living with OPAM by Daniel Butterin. So see you all then, and thanks a lot for attending this session. Can you hear me now? Okay. Let me see if I can fix this. Test. Can folks comment in the chat if they can hear me? Can you all hear me? Okay, you can hear me. It seems like no one else is getting audio, so I don't know how I'm going to run a talk. Let me see if I can add Michael's talk, and we'll get the audio issues sorted out while that's running. So here's Michael's talk.
Hello, everyone. My name is Michael Stapelberg. You're free to follow me on Twitter, and this presentation is going to be about distri with the subtitle that Linux package managers are too slow. What do I mean by too slow? Let's jump right into it and do a demonstration. So on a Debian system, when you install the ACK program, which is like a very small Perl program, you can see that this installation took 4 seconds. On distri, there is no reason why you should wait that long for such a small package. It's just a few kilobytes. So on distri, you can see that we can install in 0.5 seconds the same program. Now, of course, this effect is not only present when you're talking about small programs, but the larger the program gets and the more dependencies and moving parts it has, the more pronounced this effect gets. So let's take QEMU, which many of you will have used, and install it on Debian. And you can see that, while I'm still talking about this, it's still going on. It takes 17 seconds to install QEMU on Debian. Now, much like with ACK, there's not really a reason why this should take so long. And on distri, you can see that the QEMU package is installed in just a little over 3.5 seconds. So how do the common distributions fare in terms of installation speed? Here is a table of measurements that I have just recently updated. You can see at the link at the bottom of the slide all of the details, and that I started doing these measurements in 2019. The table is sorted by wall clock time, and you can see that Fedora is the slowest of the bunch. But also Debian, NixOS, and Arch Linux are taking more time than they could be. So you can see that the data that needs to be downloaded from the internet is different when you're installing QEMU. And this is mostly down to how finely or coarsely the distributions package QEMU and how much metadata the package managers need before they can even get started to install your program. On the very right-hand side, I have added the data rates so that you can see that a data rate of 6 megabytes per second is really not that impressive for a modern computer. All right, so why are the package managers so slow then? Let's dive into how they work. The two most widely used package formats are deb files for Debian packages, which are essentially tar archives in a Unix archive. For RPM, the Red Hat Package Manager, the situation is much the same. It's also a CPIO archive, and it has a little bit of metadata around it. The task of all of these package managers is the same. You tell your package manager you want to install a package, and afterwards you expect to be able to run the program on your computer. Traditionally, this involves resolving the dependencies, downloading all of the packages, including dependencies, extracting all of these archives, and then configuring the package so that it works with the current system that you're working on. Because most of these steps modify an existing system, they need to carefully use the fsync system call to make all of the input-output as safe as possible. So then how can we go faster? Well, there are a couple of key ideas I want to present in this talk, and one of them is to use an append-only package store of immutable images. Now that's quite a mouthful, so let's unpack it. The first part of it is that we should use an image format instead of an archive format. Distri uses Squashfs for its images, but it really doesn't matter as long as it's an image that you can mount instead of unpacking it. Secondly, we then mount each of these images under its own path, which is a concept that we call separate hierarchies. So I've put some examples on the slide. You can see the path starts in /arrow for read-only, because the packages are immutable. And then you have the full name of the package itself, the architecture, and the full version number. Underneath these paths, there are the full package contents like you're used to. So there's like a bin directory, possibly a lib directory, etc. The rest of the system, however, is laid out as usual. So you still have your /etc for configuration, your /var for state, etc., etc. The advantages of this approach is that mounting an image instead of extracting an archive is much faster. You've already downloaded it, so why unpack it again and write to the hard disk all over again? This results in much faster package installation and as a nice secondary effect also in a much faster build environment composition. So the work that packagers need to do is much quicker. Because the package store is implemented as an append-only store, that means we can use unsafe I/O and don't actually need to slow down our package installation by using all of these fsyncs. And because the package store is immutable, it's no longer possible to screw up your installation, be it by accident or by malice. All right, so in Distri, all of the packages are hermetic. And what do I mean by that? A hermetic package means that when you run the program, it will use exactly the same version of the dependencies as when the program was built for the distribution. We accomplish this by using wrapper scripts that arrange for the environment to reflect what the environment was at build time. So these wrapper scripts set, for example, the LD library path variable, Python path, PEL5lib, whatever you need for the program to make it hermetic. Now, not everything is entirely hermetic. Sometimes programs need to exchange data, and that's done on Distri via a concept that we call separate hierarchies exchange directories. So the exchange directories are directories that have a well-known path, and I have a couple of examples on the slide. For example, the man page viewer can locate the Hello everyone. My name is Michael Stapelberg. You're free to follow me on Twitter. Despite the separate hierarchies concept that we use is to just emulate the well-known paths. So on distri, the user include directory is actually a directory full of symbolic links, and the symlink then points into the fully qualified path name. What are the advantages of this approach? Well, we move conflicts from package installation time to program execution time. So when, for example, we have two separate major versions of Python 2.7 and Python 3, we only need to resolve what the Python command should mean when we're actually assembling /bin. Aside from the /bin directory, programs can be installed at the same time. So we can have Python 2.7 and Python 3 installed in the separate hierarchies. This is not only the case for major transitions, where almost every other Linux distribution will also offer you Python 2 and Python 3 at the same time, but in distri this concept is generalized, so all of the packages are always co-installable. This means you can, for example, install Z-Shell in version 5.6.2 and 5.6.3, and then do a partial update or rollback very easily if you notice that this new version of the shell has broken one of your shell scripts. It also means that the package manager can be entirely version agnostic, which entirely eliminates a large source of slowness, meaning the dependency resolution and conflict resolution when you're doing large updates. So there's no need, in fact, at all in distri for global metadata like a package list or all of the metadata files that, for example, Fedora and Debian need to download before they can get started. It's sufficient to just download the package-specific metadata. Again, the package contents and Exchange directories are both read-only. Rarely, however, programs do expect the system to be writable. For example, GNOME has a program called gsettings, which wants to create a cache in the Exchange directory. So this is not going to work in distri because everything is immutable. And I'm saying that such designs should ideally be improved upstream. In fact, when we're talking about caches, the following three rules have kind of crystallized as requirements for good caches. First of all, good caches should not be required. There should be a fallback to the slow path. Secondly, good caches should be transparently created. And third, good caches should automatically be updated when needed. Obviously, if you run into the special case where updating the cache takes exactly the same amount of time as figuring out whether to update the cache, that doesn't really make sense. Then another interesting aspect about distri is that there are no hooks and triggers in the entire system. A hook, sometimes also called maintainer script, post-installation script, there's a bunch of other words, is essentially a program that is run after package installation. A trigger, on the other hand, is a program that is being run after some other package is installed. For example, on Debian, the man database package has a trigger which runs whenever you install any other package that contains a man page, which in Debian is pretty much every package that contains a program. And then a trigger runs to update the full text search index for your man page database. I'm not sure how many of you have actually used that full text search index, but I bet that for many users, this is work at package installation time that ends up to be totally unnecessary. Using hooks and triggers also precludes concurrent package installation because all of these are typically not implemented in a concurrency-safe way. Worse, they're arbitrary code under the control of the package maintainer, so it can be slow or even have bugs. Distri's claim is that we can build a functioning system without using any hooks or triggers. This works by two main approaches. The first approach is that packages declare what they need. For example, systemd sysusers instead of calling the adduser program directly. The second approach is to move the work from package installation time to program execution time. So for example, if you think of the SSH server, you might remember that it needs a host key. On most of the distribution, the host key is created when you install the SSH program. But maybe you're just installing SSH and you don't even want to use it, or maybe just as a client. So on Distri, we create the SSH host key in the SSH daemon wrapper script so that it's created just before you actually start the program, but not any sooner. There are very few exceptions to this approach, and those are bootloader and firmware files. These are an exception because you need to install them outside of the file system. So now you might be wondering, well, okay, these are nice ideas in theory, but does it actually work out in practice? And the answer is yes. In Distri, we have built a Fuse file system for providing the /ro mount point. Why a Fuse file system? Well, it turned out to be easier to implement than managing separate Linux kernel mounts, overlays, unions, and all of the other building blocks that you would need to build it from scratch without your own file system. It turns out that it's also actually faster because Linux kernel mounts are slow as soon as you reach a number of them. The only change that you typically need to make to your packages is that you need to build the package with the -- prefix argument set to the fully qualified path within the /ro hierarchy. A small number of packages need to be patched in addition to changing the prefix argument. Some of them have path-related issues. For example, there are systemd service files that reference binaries with their absolute location, such as /user/bin/getty, or different instances of fully qualified paths that then don't necessarily resolve to the same version. So we change these to be fully within the /ro hierarchy. And then the other class of packages that needs to be patched is those that have very deep system integration. For example, the Dracut package to create your initRD, where you not only need to have Dracut copy the wrapper script itself, but also have it copy the program that the wrapper script then wants to start. Also, the removal of hooks might not be to everyone's taste. Some of these hooks are used in other distributions to implement configuration layers such as debconf or yast, which might be a wanted feature for some. So let's recap. Why is Distri faster? Well, traditionally, your package manager needs to resolve dependencies, download all of these packages, extract all of these archives that it just downloaded, and then configure the packages to work in your system. All of these, as I mentioned, sequenced by careful fsync system calls to make the I/O as safe as possible. In Distri, however, we don't need to resolve any dependencies. We only need to download package-specific metadata. Then we just download an image instead of an archive. We don't need to extract anything because we can just mount the images directly. We don't need to configure anything. In fact, there are no hooks and triggers, as I mentioned, and using unsafe I/O is perfectly okay in our case. This approach notably scales to 12 plus gigabytes per second on 100 gigabit links using just Go's standard net/HTTP library. If you compare this to the data rates of 6 megabytes per second that the other package managers achieve, that is quite a stark difference. What are my conclusions? First of all, I want to say that an append-only package store is a more elegant design than using mutable systems. It's simpler to design and build, and it allows for a much faster implementation. Secondly, Exchange directories make things seem normal to third-party software. So you can easily compile unpackaged software on Distri manually, and you can run closed source binaries no problem. And third, all of these ideas are actually already practical, because live CDs with their read-only environments and cross-compilation have paved the way to build a system this way. The project goals of Distri are not trying to build a community or user base. It's not another distribution that you should check out. Instead, it's a research Linux distribution that you can check out if you want to see how it actually behaves in practice. There are regular proof of concept releases so that you know that these ideas actually work, and then ideally you can take these ideas and influence your own designs and take them back to the other distributions. So thank you very much for your attention. If you want to learn more, feel free to check out the website at distri.org. Second I is spelled as a 1. Feel free to give me some feedback for this presentation, and I want to say thank you for your attention. We're going to have a Q&A session right after.
Can you hear me, Michael?
Yeah, I can hear you. Hey, Todd.
Okay,
How are
great.
you?
Hey, how's it going? Okay. Let's see if there are any questions in the chat. So I guess I'll give you one that you've already answered in the chat first. How many of these patches for installing into specific paths are similar to what Nix Homebrew Stack and other package managers would need to patch? And how many are upstreamable?
Yeah, in general, we have very few of these patches. It's only like maybe 10 or 20. I can take a look afterwards. And we've also tried, because it's a very good idea, I agree, to upstream these whenever possible. So, you know, if, for example, we have overlap with Nix, clearly it's good enough if one of us does the work and then actually gets it fixed upstream. Sometimes the patches might be too specific to really upstream them, or there's just no overlap with any other distribution. But often it's straightforward, and then, yeah, we should totally upstream them.
Okay. All right, thanks a lot. So unfortunately, due to the technical difficulties, I don't think we have too much more time for questions, but there aren't any over in Element.
No worries.
And I don't see any on YouTube. So thanks a lot for your talk. I really enjoyed it. And
Cool.
we did have some people watching. So thanks a lot for showing up.
Thanks.
All right,
Yeah.
I'm going to throw Daniel in. And let's see, here he goes. Here's Daniel himself. And
Hello? Hey, Todd. Can you hear me?
we can hear you, yeah.
Okay, great. Yeah, sorry for the difficulties, and many thanks to the Packaging Con organizers, to the committee for organizing this and for allowing me to speak. So yeah, today we are going to talk about the OCaml Package Manager, the OPM. It's not a very frequently discussed package manager for one reason or another, not sure why. But it definitely deserves more attention because OCaml the language deserves more attention, I believe. But in this case, I'm completely unbiased because I only contribute to the ecosystem, but not to OPM itself. So, but first, let's talk about what OPM is for people who are not yet familiar with it. So, OPM is the OCaml package manager. OCaml was first released in 96, but it was relatively late to acquire a package manager that can use remote repositories. So it's not like 57 years like with Fortran, but it's still a pretty long time. So before that, there was only a local package manager named FindLib. It can manage library link, but it didn't have a remote repository. And now OPM even has competitors. It's the Easy Package Manager that was released in 2018 that is more NPM-like. And OPM is anything but, which we are going to discuss. So, and who exactly is Daniel Baturin? So, I've been using OCaml since 2014. I got really excited about the language. It's a typed, strict, eager functional language with a very fast compiler that targets multiple native architectures and bytecode, and that's very pleasant to write, at least for me. So, and since around 2017, I've been also contributing to the package repository and to multiple OCaml libraries, and also maintaining multiple packages, so both applications and libraries, and even fixed a bug in the OCaml time once, and can stop bragging about it. So, yeah. But I'm not a maintainer of the OPM repository or OPM itself, so in this case, this is an outsider perspective. So I'm merely a contributor. So something that immediately draw attention about OPM is that some design choices are quite unusual. So first of all, even though it's released in this decade, it doesn't use project lib installations. So the libraries don't go to the project directory, and there is no package log file. And another unusual point is that the repository management is centralized, so there is no self-service package publishing. To balance the good points are excellent repository maintenance practices, very extensive CI checks that prevent broken package from appearing in the repository. It's easy making and adding third-party repos, and it's very nice UX. So for example, the shell integration for even for minority shells like Fish, not only for Bash. So it pretty much works on any Unix system, and also works on Windows. So the UX is not as nice, but it's workable. And some weak points are cross compilation and relatively large metadata size that you need to download. So now let's get to the details. So regarding per directory installations, so with AM or Cargo or many other managers, you create a project directory and you run npm install something, and it creates a local directory in the project directory, and it installs everything there. It's how Rust behaves, how Golang behaves, and that's not how OPM behaves. So OPM has a concept of switches. A switch is more or less like virtual environment. Switch includes a compiler and some installed packages. So when you create a switch, it always create a compiler installations, and then you can install packages into that installation. Normally, it's in a .opm / switch name. It can be either just version, or you can assign some descriptive name if you want to use switch to a project, for example. And then every library or every package goes under that path. So all libraries are by default shared between all projects you have on your machine, because OPM and your project are not tightly coupled. And not only there are no log files, but in fact, most packages, even end-user applications, leave Aper dependency bounds open. So it's just assumed that it's going to work when people upgrade their libraries. And I have to say there's excellent backward compatibility culture in the ecosystem. And since breaks sometimes, but it's not really a frequent occurrence. So I'm not really missing log files there, even though sometimes since do break, it's easy to pin packages if you need. So yeah, regarding switches. So a switch includes a compiler and install packages. One good thing that I really love is import and export. So you can OPM import or OPM export, and it loads or prints a list of all packages that are installed. So you can easily clone a switch. I can also use multiple switches, the same compiler version, if you feel like it. In fact, creating a switch involves bootstrapping a compiler. So since OCaml targets both native and bytecode, it can be easily bootstrapped because the upstream tables come with bytecode executable of the current compiler version. So first it uses a C compiler to build the byte time, the executor, and then it uses the byte executable to bootstrap the rest of the compiler for native machine. And it's a very fast process, so I have a really modest development machine. It's i5 Intel MFC, and it takes about 5 minutes for me, and on even more modest machines, it's more than 10 minutes. So it's not a problem. And that allows the repository to include many packs for compilers. So since they're all virtual packages, so they go back to 23, to version 3.7, that no one actually uses, but available. So if you suddenly need to compile some old application that somehow doesn't support newer versions, then it's still possible. Not a problem. So now let's get to the centralized repository management part. So I'm generally advocate of a proponent of decentralization, but in this case, I have to admit that centralized management has been a positive experience all around, except for somewhat longer time to general availability. In practice, it's usually a few days if the package is not broken. And if it's broken, then of course it can take longer to fix it and to get it reviewed again. But the first unusual point is that there's no self-publishing. All contributions to the repository are made by creating a pull request against its Git repository. And there's an APM plugin for automating PR creation. But it's still a PR, it's intuitive and asks you whether you want to create pull request. And once you create it, it's waiting for human review. But there's also very extensive CI checks, so humans don't really have to do that much review. So what are the benefits of centralization? First, anyone can fix anyone's packaging issues. So if someone discovers that an old package is broken for a new library version, they can send a pull request to add an hyperbound before an upstream fix is available. Likewise, taking over someone else's package is relatively straightforward. So if the old and new maintainers agree that someone should take over, they can just start sending pull requests in the APM repository. And there's no need to wait for anyone to pass the original Git repository to the new maintainer. And obviously, it makes supply chain attacks more difficult because a maintainer cannot sneakily update it, and a malicious actor that takes over someone's account also cannot modify the APM package by modifying the upstream tarball. So overall, I think it's been a good thing, and I'm pretty happy with the experience. So now regarding the CI checks, they're really quite extensive, and I still find it quite impressive. So if you look in build log, so you see, well, in this case, not very old. It's multiple distros, it's multiple compilers, and it's multiple architectures. So it's going back to the 14 version of the compiler still, just in case someone is using it. So architectures including like IBM mainframes and PowerPC 64. So that's why broke packages are relatively rare occurrence. And somewhat recently, they also introduced once check. So by default, it checks whether the package supports the newest versions it claims to support. So if the upper bound is left open, then it's tested with the most recent versions. But since a few months back, the CI also tries to install the package with the old dependencies it claims to support. And for many packages, the answer is that not. It led to quite a few pages to fix that. Somewhat frustratingly, it also led to unrelated packages looking broken because they had transitive dependencies that were affected by in-kind lower bounds. And I actually was quite happy to contribute to that process and help fix my package so that it could actually work with proper lower bounds, because it's better user experience for everyone. And as I said, it's easy to make alternative repositories. So if you enter the repository, for example, it's my package as a PO website generator. So it's a package name, and you have a directory per package version. So if you enter such a directory, you can see the APM file. An unusual thing is that it's custom format, not TOML, not JSON. So it's not very hard to write, and there's also a library for manipulating it automatically if you want. That library is not the nicest thing, but it's usable if you have to. So, and the repository is also Steam. So there's a link to Steam tarball, but artifacts, upstream tarballs are not stored inside the repository. And that also makes creating alternative repositories easier, because you can just copy metadata files and make your updates, but you don't need to clone every upstream tarball. And some companies are using private repositories to avoid things when they don't want them to move. So yeah, it's not very hard. And there are multiple community repositories. It's a repository for Windows that is getting deprecated because OPM is working with Windows by default right now. It cross repositories for cross-compiling for Windows and Android, and it's development multi-core repository. So even though the official repository is centralized, that's nothing stopping people from making their own and adding their own. And regarding Windows, yes, it's mostly just works now, though it depends on SIGWit. I'm only building binaries on Windows. I'm not developing that platform. But I can say that I haven't run into difficulty building it. Though people complain that sometimes using with development environments is not as smooth on Windows. So there's still some work left there. But my personal pain point is cross-compilation. So OCaml itself does pretty well. Dune, the build system, does pretty well. OCaml find lib does pretty well. But the problem is that right now you need separate repositories for cross-tool chains. And there is not much community interested. I tried to make a tool to automate the common adjustments that cross packages need, but there's not much interest, and I switched to building on native Windows, on Windows virtual machine from building with a cross-tool chain because I simply cannot keep up with the official repository, and there aren't many people who also want to help the maintainer of the repository. But I hope in the end, OPM itself acquires facility for easier cross-compilation, and it becomes a non-issue eventually. So yeah, another thing that I'm not very fond about is the size of the metadata. So since it downloads the entire repository locally, it's about 200 megabytes of data, and it's not very small. So I suppose at some point maybe some kind of proxy and the syn client would be nice because it will reduce the amount of data transferred and not packed. But I can live with it, but I still would like probably to see a syn version of the repository client. So I think that's all from me. So if you have any questions, then feel free to ask and I'll try to answer. So of course I cannot answer anything, sorry, everything, and I'm also not speaking on behalf of the OPM maintainers. Remember that.
Okay. Thanks for your talk. Are there any questions from folks out there? I don't actually see any online. I don't see any here. But all right. I think we will move on to the next talk then. Thanks, Daniel.
Actually, Jack, yeah,
Jack,
I'll answer the questions in the chat.
Oh, great. Okay. Yeah. So, what do you do for integrity of repository metadata?
Yeah, what they do is there are checksums in repository files. Let me reshare my screen briefly.
Okay. I'll put it in if you share it.
So, if you look in the repository, you have MD5 and SHA 512 checksums. So if the upstream tarball somehow changes, then the package will stop building because it will fail the integrity check. There is no support for digital signatures right in the files yet, though I hope it will be added at some point.
Any other questions? It looks like Jack has more follow-on questions. This will be the last one because we got to go to the next talk. I think Richard is already sharing, so that's great. All right, Jack says thanks. Okay, thanks a lot, Daniil. And I'm going to swap over to Richard, who
Get him over here. All right, Richard.
Hello, can you hear me?
I can.
Awesome. Okay, so I'm going to talk about the Haiku package manager. This is the package manager that's part of the Haiku operating system. I want to thank everyone for watching. It's interesting, actually. There's going to be a theme present here that was also in the prior talk, the 2 talks prior on the an improvement for packaging. So cool continuity there. So I'm just going to do a quick introduction. We'll talk about packages, and if everything goes well, I have a demo. So briefly, who am I? My name is Richard Zach. I am a Haiku enthusiast, a software developer, and I'm a cybersecurity researcher. The point here is that I am not a member of the Haiku team, and I'm not a Haiku developer. I am just here on my own. So what is Haiku? So from the website, Haiku is an open source operating system that specifically targets personal computing. Is it inspired by the BOS? Haiku is fast, simple to use, easy to learn, and yet very powerful. And we can see the screenshots of the two. They really do look remarkably like each other. One thing, though, if you can see on the screen, the GL teapot on the bottom right on the Haiku screen is showing 602 frames per second, which is pretty impressive because Haiku doesn't have any kind of hardware acceleration. So that's just all CPU rendering of OpenGL. So what is it? It's a single-user Unix-inspired desktop operating system. So if you're familiar with Linux, there's a lot of things that are going to be similar. Executable files and libraries are ELFs. Bash is the default shell. SSH is available. A lot of programs for Linux or other Unix OSs generally recompile fairly easily on Haiku. Haiku has standard tools, make, CMake, GCC, LLVM is there, Rust, Java, a bunch of others. And it's also important to note, Haiku is not Linux. It is not BSD. It is not a fancy desktop environment or anything. It's its own kernel. It has its own kernel. It has its own user land. It's its own thing. So it was inspired by BOS. And a quick note there, BOS, for those who maybe don't remember or don't know, was a company, it was an operating system made by a company called B, which was founded in the 90s by a couple of former Apple employees and VPs. And so they, of course, were heavily impacted by what Mac OS looked like. And so BOS came to look very much or have a similar feel as classic Mac OS, with some differences, of course. However, by 2001, B ceased to exist, had been sold to Palm, and BOS, of course, also then disappeared. However, that same year, one of the developers at B was able to rewrite an open source version of the kernel and basically kicked off the OpenBOS project. And that was later renamed to Haiku to avoid any kind of trademark conflicts. 32-bit Haiku is binary compatible with BOS. So if you have an Intel BOS application, it'll run on 32-bit Haiku. Of course, though, the PowerPC versions of BOS applications are not going to run. Haiku exists solely because of its strong developer and user community, volunteer efforts, and donations. There is no corporate sponsorship. One thing that is pretty cool is that this summer it was announced that Haiku had made enough money in donations that they were able to provide a full-time job to one of their lead engineers. So we have a full-time person working on it for the first time. This summer also, Haiku was successfully brought up on RISC-V, the full desktop and everything. And there is work bringing it up for ARM64, hopefully for Raspberry Pi, a couple of other architectures. And Haiku is 20 years old. So the project was formed in 2001, and the first release was in 2002. And I believe the third beta was released this year. Okay, so some of the usual features. We have a graphical interface. There's also a command line interface for looking at packages. The packages are generally separated into application packages, development, headers and things, and source. The retrieval of packages, including dependencies, comes from a repository, and it is all architecture aware. There are quite a lot of packages in there. There's lots of popular items as well, including VLC, LibreOffice, I believe Telegram is in there, and lots more. Some of the more unique features is that the packages are mounted as read-only into the file system. And the packages can indicate with metadata what libraries or commands are present. So this allows for a little bit easier dependency managing, because now you don't have to specify for a package that what is the name of the package that your package needs. You can simply specify, okay, I need lib:/JPEG. And if some other package happens to provide that, then good enough. Of course, this also can manage or specify a version if that is needed. One of the interesting things too is that the file system is aware of the package, of the package manager. So you're able to query the attributes on a particular file, and you can indicate, it will indicate to you the source of which package is the source for that given file. And one thing that is also pretty interesting is that the bootloader is also aware of the package manager. So since the package contents are mounted into the package, into the file system rather, the files into the directories are entirely read-only. This is made possible because the package itself is compressed with equally sized chunks to make it a little bit easier to have random access into the compressed file, as opposed to compressing it all together. The benefits to the user is that the file cannot be accidentally modified or deleted or intentionally messed with. I don't think there's any Haiku malware out there, but it would be more difficult for someone to modify something unintentionally. As far as the developer is concerned, it's nice because it ensures that the files that are in the package will be present on the file system in a predetermined full path. So at packaging time, you know where it's going to be, and you know that nothing else could possibly modify the files that your package is providing. Of course, this doesn't work for every piece of software. So there is a non-packaged directory that can be used to provide other things, other libraries, other things that maybe the user wishes to install. We'll give an example about that in a minute. So because the packages are also mounted into the file system, all of the packages themselves are existing on the disk, on your drive. So let's say, for example, you and some friends are traveling and you decide that you all brought your Haiku-powered laptops, and maybe a friend wants to use a particular program that you installed that they didn't install, and let's say you're offline. It would be easy enough to, let's say, just hook the computers together with an Ethernet cable, copy over the package files because they're on your machine, and provide them to the other person, and they can just install them pretty easily. So when you boot Haiku, usually it just goes right into the kernel and the whole boot process. But the bootloader does have an interesting option where it is able to see the prior state of the package managing system. So if you are working on something, you install an update, maybe things go sideways, you are able to just reboot the system and go back to however the package or however the system was at that time. So the prior states allow going back to how the system was previously. And this also includes Haiku itself. So the entirety of the Haiku operating system is also packaged. So this is great for debugging and development. Let's say you are working on a driver or something, and maybe you get a kernel panic. You can easily just reboot and go back to how your operating system was prior to the faulty code. And from an end user's perspective, they can simply just go back to how the system was, or maybe a couple of iterations prior if need be for some software. This also makes it a little bit easier to have the ability to do development on real hardware. So if you're a Haiku developer, for example, you can develop on actual hardware instead of a virtual machine, and this can act as a way to kind of simulate the functionality of having snapshots in your virtual machine environment. So there are some metadata items inside of each package. Generally, we have the basics, the name, the description, the software license. The license information does show in the Haiku depot. It also can provide the names of the library that it provides or commands. So one of the nice things is, let's say you want to install some command, and you know what the command is, but maybe you don't remember what package it is. I've had that myself where I'm trying to install something, but I don't remember which package it is in Ubuntu or CentOS, and have to pull up some documentation to figure out, well, which package has this command. The cool thing here is it doesn't matter as long as the package indicates in the metadata. You can just do packageman install command : whatever command you want, and it will find it and install it for you. Also, if there are multiple programs that might have that same command, it will show you a pop-up and it will let you choose which one you want. So if you are going to be porting software to Haiku, you may have noticed with some of these example directories that these files are not usually in the same place. So I was tinkering the other day with QEMU in Haiku and had to hard code a setting to say that the DNS resolve config file, it's the same one that you would have in Linux, but in this case, it's just in a different place. The other thing to consider is that the user's directory configuration files, the dot files, instead of putting them just inside of your home directory, there's a specified config/settings in the home directory. And again, since this is a single user operating system, the home directory is always going to be /boot/home. So again, if you were porting something, then you know exactly where the config file is going to be. We mentioned earlier about being able to make changes. So one of the things that when I was first discovering Haiku was that pip doesn't work too well sometimes, or at least when I was trying it. And there are workarounds, of course, but the problem is that by default, Python wants to install files inside of its lib directory. And as we discussed, that is read-only. So there are 3 ways to go about doing this. One is you could put the Python module in a separate Haiku package. And if you look in Haiku Depot, that's exactly what is done for a lot of these things. So Matplotlib and NumPy and other popular packages, Python modules are separate Haiku packages so that when those get installed, they can just be placed right inside of the Python library location. The other option is that you could tell pip to install inside of the unpackaged directory, and then you could update your Python configuration to add a new directory to the Python path. And final option is you could just create a virtual environment and just work from there, in which case you don't have to make any changes. So there's one more thing I'd like to show you. I got a kick out of it when I discovered it, so I figured it was worth sharing. So we are running Haiku. Let's close that. So we're going to go to the system directory, scroll down, packages, and let me open up the terminal. So let's ls boot system apps gz doom. I'm a huge fan of Doom. We've got gz doom installed. Here it is. One of the things that's interesting is you can take the gz doom package out of the packages directory, drop it. It's going to ask you to confirm that this is what you actually wish to do, and you can hit move. But if we say do up arrow, it's gone. So it's not there. However, we can simply drag the package back. It does take a sec, but then we have the package. The full path is back. The package has been reinstalled transparently. One of the other things that's interesting that I had mentioned, we can just kind of pick a random file. You can do get info. We can click on attributes, and we can see here that another aspect of the file system in the package manager is that the package manager, or rather the file system, knows which package provided the file. So this would work for any package or any file that is installed via a package. Of course, you can't always trust live demos. So I have on the slides, the screenshot just recapping what we have just seen. So yeah, boot system packages has all of the packages that are installed. That's where you could grab them and share with a friend if you wish, or uninstall something if you wish, and putting it back reinstalls the package. And we can see that there are these attributes that show the name of the package for every file that's installed. One of the things about this too that's interesting is that the Haiku uses its own file system, the B file system, and it stores and indexes all of these attributes, and the operating system provides an API for this so that essentially you can treat your file system as if it were a database. And there are a lot of applications that store their data in just this manner, where the data is stored as attributes as opposed to just creating more data files. So if there's time for questions, I'm happy to talk about that or answer anything. A couple of links here for the Haiku itself. There's also Haiku ports, where they're maintain a lot of different patches and applications that are available in the repository. A lot of the developers are always on the IRC channel, and of course there's the Discourse, Twitter, and even the Discord. Are there any questions? So how does the package manager handle updates to the live system if you can manipulate installed packages directly? That's actually a good question. I haven't looked too far into that. I know that I think what happens is that it simply updates the records for the state, so that when you go and restart, it knows to activate the newly installed packages, and making sure that you don't break anything existing. When you install a pack, I actually have a little bit of extra slides. But when you install a package, the package name gets added to, say, boot, system, bin, or lib, to make sure that if you install a package, that the package isn't going to clobber some other package. And there is I did port the Ghidra software reverse engineering program to Haiku. So there is a link that shows what a real live package info might look like. But essentially, it's a plain text file with a couple of fields filled out, and a simple command to just generate the package based on the contents of the directory.
Put another question. Does moving a pack path convert that package?
No. The only way to create the package is to use the package create command. The moving of files can be done to install or uninstall the package.
And then where does the
So if you compile the package, you could install it, and it would mount the files into the file system. But if let's say you download some open source project, what you could do here, we could just go back to this. You can use this system unpackaged directory, boot system unpackaged. And inside of there is a bin directory. And so the unpackaged directory replicates the bin, the lib, several other directories that Haiku uses. So the operating system treats them both the same, but this here, of course, being read-write. So if you wanted to install some package, that's where you could install it into your system.
Okay.
I'm sorry, I didn't quite understand that. The audio is coming off a little choppy on my end.
Getting choppy audio.
Sorry.
Can you hear me now?
Yes. Okay.
Okay. Sorry. Okay. Yes. I guess I had one last question about anything else in the chat. So you said you ported. I guess I'm curious. Things like that. Are there system assumptions that are violated by the layout or the way that Haiku works? That maybe it doesn't understand something that it would on Linux. What are the sort of porting concerns like that for something low level like Ghidra or other tools?
So Ghidra was actually pretty easy because, for one thing, is also in Java, and so it was smart enough to understand what the working directory was when you called it. The big issue there was also updating the build script for Ghidra so that it would understand what Haiku was. And then it does have a couple of C applications that it uses behind the scenes, which needed a minor modification. Only really because in one of the files, you needed to include a new .h file to get it to compile. But as far as the packaging goes, is the file system layout. In that case, it wasn't an issue, but you would know what the package would the path would be, because it would be boot system, your package name, bin, or however you structure your package.
Okay, cool. Thanks. So I think that's all the time we had. Thanks, Richard. I thought that was a great talk. And we're going to head over to Norbert Preuning. Thanks a lot.
Bye.
All right. Hi, Norbert.
Hi.
You're on. So we're going to talk about tech package management.
Yes. Good morning, everyone. Good morning for you. It's probably evening. For me, it's early morning. I had a long night enjoying most of the talks here in Japan. It's 5:40 in the morning. So I want to introduce you a bit to TechLive packaging and what we have faced with respect to multi-platform support. So for a start, if you see this and you start crying and running away, don't panic, please. Yeah, this is not what we are discussing today. So I won't go into the convoluted tech language that is used, but more into the packaging. A bit about myself. I'm a mathematician and computer science, doing mostly formal mathematical logic. I'm also the head developer of TechLive, author of the tech infrastructure, the TechLive manager, security stuff, all kind of stuff. I do also quite some in Debian, mostly Tech and the KDE Plasma area nowadays. And if I have time outside, I'm also a professional mountain guide and hanging around in the mountains. So Tech, for those who don't know, so it's a typesetting language. You write like a normal text input and compile it to DVI, or nowadays mostly PDF output. It has been published, well, the first written by Don Knuth, famous for computer scientist for algorithm. First release was in the late 70s. Interesting fact is that it has a paragraph formatter 30 years before Adobe introduced it in InDesign. InDesign got it like 5 or 10 years ago. And it has superior mass step signaling, but a lot of other things. A funny thing about the history, just in the very first talk, plenary talk in this conference, CTAN was mentioned as the oldest one, and Joachim, with whom I often converse, was quoted here from the Eurotech. So yes, CTAN was the first, let's say, language community, and it's still thriving. It makes a lot of errors that was later fixed by, especially when compared to Gran, but well, we'll see later about this. So the history of TechLive, it started actually around, beginning of the 1990s with CDs that were created from the Dutch user group. In 95, it was based on TTech. TTech was Thomas Essertech, who compiled this, and that was also distributed within the user groups. And the first edition called TechLive was 96. Back then, it was actually runnable directly from the CD. We had several editions with free software removed, non-free software moved, and macOS support added. Since 2006, Carl Berry is maintaining everything. And in 2008, that was turning point. I will talk about this later on. The new network infrastructure was added with network installation, updates, TechLive Manager, and all kind of stuff. There are lots of other things going on, but not of interest. So to give you an idea, we still distribute DVD images. We actually press images and send them out to, member of user groups. It is distributed with books. This is normally done in March. Nowadays, it was a CD before, now it's DVD. We're on the limit of the DVD size already. So and then it's a network distribution, so you can install and update over the network. We have more or less daily updates of packages according to what CTAN gives, and TechLive Manager, what we're discussing here, is doing all the management. Just to give you an idea, because before CTAN was mentioned as package management name. So CTAN is actually not the package managing, it is an accumulation of whatever the authors upload in whatever format. So CRAN, the RNAT network, has a very strict format requirements. We don't have this. This is a big problem with CTAN because it makes importing from CTAN quite a complicated thing. So what is TechLive? TechLive is what closest comes to what before was mentioned as is getting everything from CTAN in a ready consumable way so that you can install it with a package manager, you can delete, update, all this kind of stuff. At the moment, around 4,000 packages and a gigabyte of total installed size. It's multi-platform. I will come to this later on. It's also uniform across platforms, so we try to have the same behavior across all architectures and platforms. We have their own package manager, TechLive Manager, daily updates, and the FSG. Well, growth is as well, just usual. We have linear growth, I would say, over the last 15 or 20 years. Actually, we have the history of all the stuff is in a Git repo, originally in a Subversion repository. So multi-platform, what does it mean, multi-platform? It has been mentioned today many times, and it is quite often. So for us, that means not only architectures, because there are quite a lot of it, means also operating systems. Actually, here we should add operating systems with libc versions, because nowadays we have also glibc and musl and USL libc systems that have to be treated differently. And well, all of these are the platforms we are running on. So to give you an idea of what other famous projects who are famous for multi-platform, like Go claims to be extremely multi-platform. They support, well, a few BSDs, a few Linux, macOS, and Windows. LibreOffice is even worse. To give you an idea what TechLive has, we have about 450 programs, of which 150, 160 are binaries, so actually compiled stuff. And we support at least these are out of the box on the DVD. So Cygwin, BSD, Linux in all kind of variants, Linux with MUSCL, macOS, old macOS, BSD, Solaris, Windows, and we have several others that normally don't fit on the DVD, like Alpha Linux, MIPSL, IRIX, IX, HappyBux. So stuff that some of them actually got lost over time because we don't have the hardware anymore available. But all of them are supported in principle running. And for many of them, there are still binaries in the online network, but not on the DVD anymore. So how to achieve this? So that for us, there were a few things. First of all, I have to say, despite the general move to XML in many areas, we moved in the different direction. We moved from XML to human and machine-readable configuration files that based mostly on the Debian packages files, so stanza-based, so a paragraph, a stanza, and plain text files. Then implementation language, that was probably the hardest decision, and it turns out there is not much option if you want to have something workable on all different platforms I mentioned before. There leaves Perl. I will discuss a few things about this, and then a strict separation between auto-generated and static content. So human versus machine readable. So before 2008, we had this as input data. It was called TPM, Tech Package, I don't know what it was for, Tech Package Manager, I don't know. Actually, these files are still in use, probably, as far as I remember, from MikTeX, a Windows-only distribution. So the point is, the problem with this was there was hard to parse with standard Unix tools. If you want to parse it with some command line or a shell or whatever, you need libxml or whatever to parse it, which is a library which is not available on many of the systems we are supporting. And in addition, it had a lot of static and generated content mixed together. So that was something I didn't like. What we have now is the input is this, an empty file. Yes, it's just an empty file, and the output, we generate from that the object that is, so to say, the main entry in the database. That is everything generated automatically based on of course, some settings, but this is for all of them. So that is something, a clear separation between input and output. You see also that the format is very close to what Debian package files looks like. So like key values, simple key values, and then you have lists of files into 3 or 4 categories. So why did we choose the format? It's human readable. It is Unix tools readable, grep, set, whatever. I mean, counting how many files are in the database, or easy checking on consistency, like whether a file is mentioned 2 times, is very easy because, well, you have all the tools at hand. It's also easily parsable in all kind of programming languages. You don't need a lot of heavy libraries, and it's easy extendable, this format. And your daily cron job will be happy. So we have a lot of cron jobs running, updating the daily system. So why not XML? As I said, because it is really hard to parse it from shell or from other without some heavy library that is not available on many systems. So the implementation language I mentioned before, it's Perl, because it's everywhere. Perl is the only language that you find on every, well, besides Windows, where we ship it ourselves, but besides Windows, on every system. It has proper model system, it's fine. So we considered Python, but at that time when we wrote it, there was Python 2 versus 3 disaster, which still continues. And Python is still not installed by default on many systems. C, of course, or C++ would be nice, but compiling, I mean, writing the whole stuff in C would have taken much longer. Perl was quite convenient. Okay, a bit about TechLive Manager, the package manager. So, yeah, it started actually as a Lua script. Well, very, very early in 2006 or 7, and soon changed to Perl. First, it was only responsible for changing a few settings of an installed TechLive. And while over the first year of usage or writing, I implemented online updates. And so, while a packaging from the server side, that we provide packages on the server and that we can actually update this. So a typical run is like download databases. Similar to Debian, you can have several repositories. Different to it, we have pinned repo, so we have one main and sub repository, not all are the same level. Check for newer packages. This is trivial, I mean, just by comparing revision numbers with pinning, because you can say you want the package always from this that specific repository. Then download the containers. So we have containers for different types of files, like the source files, the documentation run, and binary files, and update them to the database. So that is quite standard. I think also the logic behind determining updates and the order of removals and updates is quite straightforward. What is quite important is a certification or verification about that you don't get rubbish on it. At the end, people install binary programs from there, and with an usual tech document, this is also well documented. You can hack also a lot of strange things. So what happens, TechLive Manager optionally, but by default it does, TechLive Manager verifies the authenticity of the database using GnuBG, and then checks the integrity of all the containers that are downloaded and installs the package. So what does it mean, the authenticity? So we have the TechLive database you see here. It contains for every container the checksum, SHA-2 512 checksum. And this file is, the database is again checksummed with SHA-512, and the checksum is signed. So TechLive Manager downloads the checksum and the signature, checks that everything okay, uses the cached database or downloads a new copy of the database, verifies that the checksum and of the database agrees with the downloaded checksum, and by that has a guarantee that the contained checksums of the container are correct. And after that, downloading the containers and checking only the checksum of the SHA-512 checksum of the containers. So this way we guarantee that what we are creating on our main server and shipping out via the CETA network, because we don't have a control over the mirror system. It's often provided. CTAN mirrors are often provided by universities or companies or, I don't know, user groups. So could be that there's some bad players there. So the Tech Life Manager will cry out if there is some inconsistency. Of course, there is a lot of testing before shipping out. I mean, it's everything on a much smaller scale. I mean, I was impressed about the Conda Forge discussion presentation about how many packages. On the other hand, how many people work on Tech Life. It's a two-man show. It's Carl Berry and me doing all this stuff here. So normal package, we work on functionality tests of updated packages. But that is very tricky because Tech is a bit nasty package language to check. The infrastructure, the main packages themselves, they are tested. There's also a staged install, so we don't ship them out automatically. We have a separate repository that Tech Life Critical that contains the next release that people can test, just in case bugs creep into the infrastructure stuff, and that is pushed out once in a while to the normal users. And then we do a full consistency installation test, full installation test of the Tech Life consistency check, all this before pushing out to the main CTAN network, and from where everything is mirrored out. What are these consistency checks? As normal is that all files are there, all packages are there, the execute statements and dependencies are correct, and a full installation. So to conclude, a few things. So first of thing, multi-platform is hard. Actually getting binaries for Tech Life compiled is considerable endeavor. So in preparation for the DVD, we freeze for normally 1 week to 6 months because getting everything compiled for all the systems is rather challenging, especially with several libraries we include, like HalfPath. Bumping up the C++ levels higher and higher, we have to go to newer and newer distributions, which get you newer and newer glibc, which gets you incompatibilities running on older systems. So that is every year a hard fight. The language options, as I mentioned before already, they are quite restricted. So we cannot really use any other language. I was thinking about getting it to writing it in Lua. Why? Because Tech, there is Tech Lua. This is Lua Tech, one engine, one core engine. Nowadays, so it's a Tech interpreter with Lua built in. So you have a Lua interpreter also with the Tech interpreter. So that would be, because we don't, it's automatically, we have a language where we can write, but rewriting everything in Lua is a huge work I don't want to do at the moment. What I would like to see is a better integration or interaction of Tech Life Manager with distribution. So this is quite, I mean, I'm also packaging for Debian, so I know what this means, but it is, so we have this user mode, but it's not optimal. It would be better to have better interaction with distributions. Then what is also a huge problem is, sounds trivial, but actually it is downloading lots of files. We have, as I said, we have 3 to 4 container per package times 4,000, so it's 12,000 files that often get downloaded for an installation. And to get this working somehow uniformly, well, you don't want to have code paths for everything across all platforms is a pain. So we use LWP to get a stable connection and keep them up, but it falls back to curl and the wget. And I just mentioned certificates because it just popped up again. I mean, the Let's Encrypt ISGRG root X1 problem is still beating around. So yeah, it's surprisingly difficult to get this right. Then CTAN, as I mentioned before, so I wish always, and I hope, but it will not change anymore, for stricter rules. I mean, like CRAN has extremely strict rules of the format of what is uploaded. So that is something that would be really helpful for getting the distributing because we could directly install from CTAM, like CRAN, the CRAN manager installs directly from Grima. This is something we cannot do at the moment. And I mean, something, because it was discussed here, reuse of some universal package manager would be nice, but I haven't seen any of the package managers being able to run on the set of systems we are supporting, even the reduced set of systems we are putting onto the DBT. Okay, some resources if you want to check back. So the main website is on the tag.org TechLive. That's the main website with all, well, user documentation, developers documentation, all kind of stuff. There is a web view. So the main repository is a Subversion repository. Actually, we had before we had a Perforce repository, but I think that is long forgotten. We only have the log files. So the Subversion repository goes back to 2005. And the Subversion repository is here with several trunks. And I, for my own, and because I don't like Subversion anymore, I run a Git SVN mirror since also quite some time. Free to clone, just be careful, it's 50 gigabyte at the moment, but it contains the complete history, and yeah, just in case you want. In case for contact, so there's techlive@tag.org. This is the mailing list for a user, but for any kind of everything is discussed there. There's specifically for distributions a mailing list in case you're interested, and of course you can always contact myself also. So the 20 minutes are over. Thanks a lot for your attention, and we're looking forward for any question or requests or everything. Thanks.
Hello, Norbert. I'm jumping in for Todd because he had to run to some work emergency. So let's see if there are any questions.
Everyone is tired.
I guess you're also in Germany or somewhere close. Are you also somewhere in Germany or?
No, I'm in Japan. It's 5:30 in the morning now. I stayed up all night and enjoyed all the talks, but now I will drop into bed for at least an hour or something.
So someone is saying, thank you for your service.
Well, I see many packages here doing voluntary service, right? This is quite common. It's rather a rare case that some company employs or sponsors this kind of work.
No.
Yes.
I think all this packaging is very valuable for the entire economy. So
do you have broad thoughts on the role and future of tech? Of course, I mean, the reality is that a lot of things are done nowadays in the usual products, but I think tech is still strong. For example, here in Japan, actually, quite a lot of publishers use tech for book production. Nowadays, we have also ebook production using tech. It is still used, so I myself, well, besides writing my own papers and this kind of stuff, I use it for, I also did study Tibetan or write Tibetan text or Sanskrit text and this kind of stuff. Many things that are really hard to do with other products, I have to say. Also, I have to use them. Broad thoughts on the role and future. I mean, it is very good for every automated system, like automated receipt generation system, invoice system. So that is something where a lot of people are using something like tech related, often generated from XML. So there was XML tech at some time. I'm not sure how good it's running, but there are different systems now where you can feed in XML into a pipeline to generate, because that is what nowadays quite often used. And of course, then there is roles on, well, book or technical documentation or whatever kind of documentation publishing. I mean, fortunately, nowadays we can write most of the things in Pandoc and convert it in Markdown and use Pandoc for publication. That is for what I use a lot for technical documentation. I think tech will not go away. For that, it is has been here for too long, and it's growing actually, the use from what I see. Of course, it will not take over world domination. That is something. If you remember the first slide of the Marco package, then it's somehow obvious that only some maniacs who enjoy writing special code will actually use this for programming.
Right, here's another question.
Well, I always feel sad that we never got good HTML output of scientific papers with Tech. Well, that is a good point. There's Tech for Hypertech that has been dormant for quite some time, in particular also because the main developer passed away a few years ago, but has seen quite some activity recent. The output of Tech for Hypertech is a very opinionated HTML code and makes it very similar to the actual Tech document, which is probably not what most people would expect. Right, there are other converters that are in this sense a bit better because you can much better, because they parse, like to say, abstract document structure out of it, where you can better configure the output that is generated on their HTML side. There are a few projects here. LaTeX-ML is mentioned in the Matrix chat. I think it has been greatly improved. I mean, there are even different stuff. Is like that you can PDF viewer in the browser, right? I mean, nowadays it's very common. Yeah. Read academic papers from archives web pages. Yes. Yeah.
Okay, I think unfortunately we have to slowly end the broadcast of the last talk for today and for this conference, actually. We still have a bunch of lightning talks coming up.
Yeah.
And maybe, Norbert, you can join
in
the
Element
Matrix
room
chat,
and
I will.
Yeah, I'm there.
Answer some
will
questions
answer.
over there. Oh, cool. And yeah, hopefully we see everyone again next year or now in the lightning talks. Thanks again.